हाँ भाई बताओ. So in CRE we have completed till that non-ideal reactor, no? So we have completed our homogeneous part, we have completed the non-isothermal part, and we have completed till the uh, and we have completed till that non-isothermal, the homogeneous part, everything we have covered. Non-ideal part is covered. Okay, so I hope you are solving the questions and you have solved the questions. Any doubts in the questions that you are solving? बताओ, क्वेश्चंस में कोई डाउट है? ठीक है. So only our the last part that was left, that is our heterogeneous part. Okay, so in heterogeneous part, the things that are there is, okay, first is the basics. First is your basics of heterogeneous. Okay, the second thing is your that is your pore diffusion. Okay, and at last there is surface kinetics. And at last there is surface kinetics. Okay, and after that some reactors are there. Some reactors are there. Okay, that is your basket reactor and your packed bed reactor. So these two reactors are there. उस दिन का होमवर्क बता देना. ठीक है, चलो बता देंगे. So till here we have covered it. Okay, so sorry, so till this much a portion we need to cover. Okay, the second thing is that some new added part is also there, that is your catalyst deactivation and your enzyme kinetics. Okay, but the thing is that this part was introduced in 2021, okay, by IIT Bombay, and since 2021 to 2023, no such question has came from this. Okay, the questions that has been asked from this, no, this enzyme kinetics and your catalyst deactivation, they are like normal. Like if you can just pick up the paper, so that is normally your normal aptitude questions have been asked. Okay, so not such defined question is asked. Okay, so this part we can cover it later. Okay, this part is not that much important. This much is important because this much is our base syllabus. From here many questions has been asked. Okay, so this one we will cover it now. Okay, and this part, that is your the newly added part that was added in 2021 and no question is asked from there. Okay, so this part is not that much important. Okay, so maybe one question is asked. Okay, so we will cover a part, but maybe the part like from that part question comes or it doesn't come. Okay, so that is not a like important part. So this we will cover after our entire syllabus is over. Okay, this part is there, and from your mass transfer, that membrane separation is there. Okay, membrane separation, these two things were added in 2021 and not such like good questions. Okay, like defined questions has been asked from there, so no need to waste time on this now. First we will cover our entire syllabus, all these subjects, then we can look into this. Okay, so this you can leave it for now. This not required for now. This one at the end we'll discuss it. Okay, however this part, that is your heterogeneous part, this is very important, and this part we will cover it. Okay, so let's do it one by one. So first is your basics. So what we said in our homogeneous part was that our rate of the reaction was defined as 1 by v into dni by dt. Okay, this was for our homogeneous reaction. Okay, homogeneous means either purely liquid phase or purely gaseous phase, Okay, whenever we will come to our heterogeneous part, heterogeneous whenever we will come to our heterogeneous part, please understand this heterogeneous will involve a solid phase will be there. Along with that solid phase, it can be either liquid or it can be gas. Okay, so what is basically happening is that you have a solid catalyst. What is basically happening in this heterogeneous reaction is that you have a solid catalyst. Okay, suppose this is a solid catalyst is there, and surrounding it will be our bulk gas or bulk liquid, anything. Let us take the example of bulk gas. Okay, suppose in this bulk gas our reactant A is present. Okay, this A is our reactant. So first what will happen is that this bulk that is this reactant A from the bulk gas, it will diffuse onto the surface of this, it will diffuse onto the surface of this catalyst. Okay, this is your catalyst, that is your solid phase. So now, whenever we are introducing this solid phase catalyst, now the overall reaction becomes one solid phase and plus gas phase. So two phases are present. That's why it becomes heterogeneous. Clear? In homogeneous, it was either liquid phase or purely gaseous phase. In heterogeneous, what will happen as we are using a solid catalyst? So what is going to happen is that this reactant A is going to diffuse onto the surface of this catalyst. So now two phases are there. One is your gaseous phase and one is this solid catalyst phase. So two phases, so it is becoming heterogeneous. Okay, as simple as that. So this reactant will diffuse onto the surface of the catalyst. So what is going to happen here? Mass transfer is going to happen. What is going to happen? Mass transfer is going to happen. And once this reactant A reaches this catalyst surface, A is present here. Now this participates in a reactor, participate in a reaction, and it's converts into a product. So this is the basic idea. So there are several steps are there. Okay, that several steps we will look into later on. Okay, some steps are there that how this thing actually happens. First let us get an overview, like why this thing happen and how this thing happens. First let us get an overview, then all the steps involved in this we will look into it later on. Okay, so this is the basic idea. Suppose you are having two reactant, so no problem, another reactant B will also be there. It will also diffuse onto the catalyst surface, reach till the catalyst surface. There it will again, then A plus B will react and it will form your product. Okay, so like this is the basic idea of your heterogeneous reaction. So till here it is clear, no? And as because here the catalyst is involved, so here the rate of the reaction, Ri, you can note it by single dash or double dash. Okay, so those things are just notation, doesn't matter. Okay, the idea must be clear to you. 1 by W into dni by dt, and the second format is Ri double dash, that is 1 by S into dni by dt. Okay, what is this W? What is this W? What is this W? This W is simply the weight of the catalyst. Weight of the catalyst. Okay, and what is the unit of this Ri now? The Ri unit is mole per kg second. Okay, this mole comes from this Ni, this second comes from this time, and this kg comes from this W. Okay, similarly here what is the unit of your Ri? Oh, sorry, here what is your this thing S? This S is nothing but surface area of catalyst. Surface area of catalyst. Okay, this catalyst is offering some surface area, no, for the reaction to take place. So that surface area is your this S. It is denoted by the unit, that is your meter square, as its surface area is a meter square. So now your Ri unit will be mole per meter square second. Okay, these two rates we use it for our heterogeneous reactions. Okay, in your homogeneous you were using 1 by V into dNA by dt, but in case of heterogeneous you will be using 1 by W into dNA by dt or 1 by S into dNA by dt. Clear? And these notations, no, that Ri dash or Ri double dash, these are just notations. Okay, it doesn't have any physical significance. It just separates it out that we are if we are denoting the rate for your homogeneous with the help of V, then we are writing it Ri with respect to weight of the catalyst, Ri dash with respect to surface area of catalyst, Ri double dash. Okay, nothing is there. Okay, and from here some simple relations are also, like one simple relation is also there. Okay, everywhere, like very basic, you will see everywhere. So what is that? Is that you write your dni by dt. Your dni by dt is equals to V into Ri, that will be is equals to W into Ri dash, that will be is equals to S into Ri double dash. Okay, so this thing is there, very very basic, very simple, school level thing. Clear, no? यहाँ तक बताओ, तो फिर हम लोग थोड़ा सा आगे बढ़ जाए. ठीक है, चलो अब थोड़ा सा आगे बढ़ते हैं, थोड़ा सा समझते हैं मैकेनिज्म. लेट अस अंडरस्टैंड द मैकेनिज्म ऑफ दिस कैटलिस्ट रिएक्शंस. ओके, लेट अस अंडरस्टैंड द मैकेनिज्म ऑफ दिस कैटलिस्ट रिएक्शन. सो व्हाट इज द मैकेनिज्म इज दैट वी वॉल्यूम ऑफ रिएक्टर है या वॉल्यूम ऑफ कैटलिस्ट? नहीं, वॉल्यूम ऑफ कैटलिस्ट हम लोग यूज नहीं करते हैं. वॉल्यूम ऑफ कैटलिस्ट हम लोग यूज नहीं करते. वॉल्यूम ऑफ कैटलिस्ट का कुछ मतलब नहीं होता है ना. Catalyst, either you use the weight of the catalyst or your surface area of the catalyst. This V is for your homogeneous. Okay, it is either the volume of the reactor or the volume of the reaction mixture. If it is liquid phase, it is volume of reaction mixture. If it is gaseous phase, then the volume of the reactor, as because the gas will occupy the entire reactor. ठीक, हाँ चलो. Now let us see. Suppose this is your catalyst surface. Okay. Suppose this is your catalyst surface, and this is your bulk gas or bulk liquid, anything you take it. Okay. Suppose here A is present. Okay. Reactant A is present. This reactant A, it will be reaching this surface and it will convert into product. Okay. Like this. Okay. Very simple. This thing is going to happen. This is your solid catalyst. Okay. So what is going to happen is, suppose in the bulk, the concentration of the liquid, in the bulk liquid, the concentration of your A, it is CaL. Okay. So it will come till here. This is the interface. From the interface, it will go down and it will reach here. This is the surface concentration. It will see we denote it by, let us denote it by CaS. CaS. Okay. CaL means concentration of A in bulk, and CaS means concentration of A at the surface. Okay. This thing is going to happen. Okay. Let this be our liquid film. Liquid film. Okay. Liquid film means you're getting it. No, suppose you are having a spherical catalyst, so you have dipped it into a liquid. Okay, like this, a liquid you have dipped it into. So what will happen? A liquid film will cover it. No. So what is going to happen is that, so from this bulk liquid, this molecule will diffuse till here. From here again, it will diffuse till the surface. Okay. Till from here, it will diffuse to the surface. Now, as it is diffusing to the surface, some resistance will be there. That is your mass transfer resistance. Okay. Once it diffuses till here, it is reaching the surface. Then once it reaches the surface, then your surface reaction takes place. Okay. So that is the basic idea. So let us see what are the steps involved. Okay. So suppose this is our basic overview of our heterogeneous reaction. So from here it is very clear that two steps are going to be involved. The first step is your mass transfer step. Mass transfer step. Mass transfer step means this diffusion of this reactant A from this bulk liquid or bulk gas to the surface of the catalyst. This is involving mass transfer, no? So this is known as your mass transfer step. The second step is your reaction step. Reaction step means once this catalyst, once this reactant A reaches the surface of the catalyst, so now it will convert into your product. Okay. Now it will convert into your product. This catalyst is providing the surface area, required surface area. Okay, it is decreasing the that thing. It is the energy barrier. Okay, the activation energy, all these things, it is decreasing, and at a particular temperature, it will react. It will like convert into your product P. Okay, this is going to happen. So this is your reaction step. Okay. Now, from here, it must be clear to you that this concentration CaS, this concentration is available to us for this reaction. You're getting it, no? The bulk liquid concentration, it may be 10 mole per meter cube, but this concentration is not available to us. Suppose for diffusing, it has reached here and it has become 4 mole per meter cube. This CaS, this 4 mole per meter cube concentration that has reached the catalyst surface, this is available for us to participate in the inside the reaction. This is available to us for our reaction. Clear? No? This thing is clear, no? Okay. One more thing. Rate the so not here. Let the rate of this mass transfer step. This rate of the mass transfer step, let us denote it by RMT. Okay. And the rate of this reaction step, let us denote it by R reaction. Okay. R reaction. Two rates are there. Okay. Now two things can happen. What are the two things? These two steps, these two steps can either be in series or they can be in parallel. Okay. These two steps, either it can be in series or it can be in parallel. Okay. In general, it is in series only. Means first this step, mass transfer step will happen and then the reaction step will happen. Okay. Generally, these two steps are in series only. Parallel means what? That both this mass transfer step as well as this reaction step, they are continuing in the parallel, in parallel format. Okay. Matlab both are continuing in simultaneously. Okay. So that is very like uh, rare thing that we do not deal with. Okay, we generally deal with our series thing, that first mass transfer will occur, this reactant A will reach our catalyst surface through diffusion, and then our reaction step will occur. The reactant A that has reached the catalyst surface, that will participate inside the reaction and it will form our product. Okay, if it is series reaction, then we say that R overall, that overall rate of the reaction, overall rate of the entire heterogeneous reaction, R overall will be is equals to our R mass transfer. That will be in turn is equals to our R reaction. If it is parallel, then our R overall will be is equals to our R mass transfer plus our R reaction. Okay. These two things will be there. Clear? Or you can also directly write it as sum of all rates. Individual rates, we will sum it and we will get our R overall. So two steps, either if they are in series, so your R overall will be equals to R mass transfer, that will in turn be equals to R reaction. And if it is parallel, then our R overall will be equals to R mass transfer plus our R reaction. Okay. Okay. Now what is your R mass transfer? What is the mass transfer rate actually? The mass transfer rate can we write it as KAL into CAL minus CAS. Can we write it like this? Batao. This will become in the format, what will be the unit of this? Mole per meter square second. Mole per meter square second. Nothing. It is just the flux Na. It is just the flux Na. That is your mass transfer coefficient MTC and into your concentration difference. This we have already done in your mass transfer. What is the unit of this mass transfer? Meter per second, and concentration difference is mole per meter cube. So this in turn will make it mole per meter square second. Clear? What will be this R reaction? R reaction will be is equals to K into CAS, isn't it? And let us denote it by K double dash, or let us denote it by K dash only. Weight of the catalyst. Okay. This is based on the weight of the catalyst. So if it is based on the weight of the catalyst, then what is the unit of your R reaction? Just now we have seen, not weight of the catalyst. Let us denote it by the surface area of the catalyst. So it will become mole per meter square second. This rate we are taking it. This rate we are taking it. As because this catalyst is providing the surface area of the reaction, so we are considering this rate, Ri double dash, that is equals to 1 by S into dNA by dt. What is the unit of this? Mole per meter square second. That is your mole per meter square second. This K double dash is the rate constant corresponding to your Ri double dash. Okay. What is this K double dash? It is the rate constant corresponding to your Ri double dash. Okay. For your Ri, we were using K. For your Ri dash, we will be using Ki dash, and for your Ri double dash, we will be using K double dash. Okay, just the notation, nothing. Just separate notations. This is just notifying that we are defining the rate with respect to the surface area of the catalyst. Okay, it is not having any mathematical significance. Clear? This thing is clear, no? Just the unit will be changing. Just the unit will be changing. Okay, what will be the unit of Ki dash, the Ki double dash? What is the unit of your concentration? It will be mole per meter cube, no? So for balancing the unit of your K dash, K double dash must be equals to meter per second. यहाँ तक समझ में आया? बताओ. ठीक है. And of course we are considering a first order reaction. N equals to 1. Okay, this is our assumption. ठीक है. ऐसा नहीं है कि हम लोग कोई भी रिएक्शन के लिए ऐसा लिख देंगे. सेकंड ऑर्डर होगा तो भाई सेकंड ऑर्डर के लिए CAS स्क्वायर लिखना पड़ेगा. Okay, according to that our unit will be changed. Clear, no? According to that our unit of our K double dash will be changed. Okay, doesn't matter. This is our assumption that we are seeing it for the first order reaction. Okay, if till here it is clear, then what we said is that our RMT will be is equals to our R reaction. This we said, no, that our R mass transfer will be is equals to our R reaction for our series reaction. Both these steps are in series. Okay, and let us consider them to be in series only. Okay. So now what we can do is that you can write KAL is equals to KAL into your CAL minus CAS equals to your R reaction, that is your K double dash and CAS. Okay. From here, what you have to do is that, see here, what is our unknown concentration? What is our unknown concentration? The unknown concentration is our CAS, no? The unknown concentration is our CAS, no? This bulk liquid concentration you will be knowing. Okay, because the bulk liquid you are having only. So bulk liquid concentration you will be knowing. Okay. This rate constant, the mass transfer coefficient, they comes from the theories, so that also you will be knowing. The only unknown thing is your CAS. So let us find out the value of your CAS. Let us find out the value of the CAS. So what is the value of our CAS? So from here, KAL minus KAL is equals to K double dash CAS. From here, your CAS will be is equals to KAL into CAL divided by KAL plus K double dash. This will be the value of your CAS. Once you find out your value of your CAS, you know that your R overall will be is equals to your R empty, and that will be in turn be is equals to your R reaction. Okay. So can you write it your R overall as your K double dash into your CAS? You can write it, no? Nothing. We have just written it in the terms of your R reaction. As because it is a series, so all the rates will be same. So that will become K double dash into what is the value of your CAS? It is KAL into CAL divided by KAL plus K double dash. Okay. And from here you can write it as CAL divided by 1 plus KAL plus 1 by K double dash. This will become your R overall. Okay. And from here only we define two things. That is, the first case is that when your KAL is much greater than your K double dash, and the second case is that when your K double dash is much greater than your KAL. Okay. When your KAL is much greater than your K double dash, then what will happen is that your 1 by KAL will be much less than your 1 by K double dash. So with respect to this 1 by K double dash, this 1 by KAL can be neglected. With respect to this 1 by K double dash, this 1 by KAL, this can be neglected, no? If this can be neglected, so your R overall, if this can be neglected, so your R overall will be equals to your CAL divided by 1 by K double dash, divided by 1 by K double dash. Okay. This is nothing but your driving force by resistance. Okay. And what is this resistance? This resistance is your surface reaction resistance. This resistance is known as your surface reaction resistance. Okay. And from this only we say that our reaction is surface reaction controlled. समझ में आया? जो हम लोग बोलते हैं कि हम लोग का जो हेट्रोजीनियस रिएक्शन है, आइदर इट इज सरफेस रिएक्शन कंट्रोल्ड और इट इज मास ट्रांसफर स्टेप कंट्रोल्ड. Okay, we say this, no? So we have to determine that which step is controlling. Okay, this type of questions you will see it has been asked. So from here we define it. Okay, once you get your R overall as your CAL by 1 by K double dash, that is nothing but your driving force divided by your resistance. So this resistance is what? 1 by K double dash. This K double 1 by K double dash is what? Nothing but your surface reaction resistance. समझ में आया? बताओ भाई. ठीक है, तो क्या हो रहा है? So this is one way of understanding. Okay, now physically you understand that this KAL is much greater than this K double dash. Means what? If this is happening, that means what? This KAL is your mass transfer coefficient. If your mass transfer coefficient is high, then your mass transfer rate will be high, no? Mass transfer rate will be high. That means your mass transfer rate is higher than the surface reaction rate. Now you tell me, any process is there, what we have learned, that the slowest step is controlling the reaction. Any process from childhood, from 11 12, since we are reading chemical kinetics, you have always learned a statement that the slowest step is the rate determining step. Okay, so what is the slowest step here? This one is the slowest step, no? Because this mass transfer rate is high. So as this is the slowest step, so this will be the rate determining step. As simple as that. Or you can call it in a different way, that this is the rate controlling step. Or you can say the surface reaction is the rate controlling step. Clear? So directly you can say it from here also, or you can do it mathematically and check it from here also. Anyways you can do. Okay. Similarly for this one, what will happen? This K dash is much greater than your CKL. So 1 by K double dash will be much smaller than your 1 by KAL. Okay. From here your R overall will be equals to CAL divided by, so with respect to this 1 by KAL, this 1 by K double dash can be neglected now. So this will become 1 by KAL. So this is again your driving force by your resistance. And your resistance is what? Your empty resistance, mass transfer resistance. Okay, so now as because only mass transfer is providing the resistance, so this will become empty step will become the rate controlling. Clearly? Similarly, from here also you can directly tell that as this is much higher than this one, so what will happen is that your surface reaction rate, your R reaction, R reaction will be much higher than your R empty. Okay, so that means this one is the slower one. If this one is the slower one, then this one will be the rate determining one. Okay, or you can also call it as the rate controlling step. It is your mass transfer step. बताओ ये चीज समझ में आया? अरे, this thing is clear, no? Now suppose any unknown reaction is given to you and you have to do it, so you will be able to do it, no? You will suppose any unknown reaction is there, so you will be able to derive this first of all this R overall you will be able to derive. What things you have to learn from here? See, the first thing you have to learn is that to represent this R overall with respect to the known quantities. What are the known quantities? This mass transfer coefficient, this rate constant, these things will be your known quantities, and this bulk concentration, this will be your known quantity. Clear? This surface concentration, no, this is your unknown quantity because you don't know that at surface through after the diffusion what will be the concentration. So first step is that you substitute, you make this as a subject and you equal both the rates and you find out this value of your this thing, your surface concentration. Once you find out the value of your surface concentration, you substitute it in the R overall and you find out this kind of equation. Once you find out this kind of equation, now from there the cases that will be given to you, based on the cases, either this case will be given to you or this case will be given to you. Based on that you can directly say that which step is your rate controlling step. ठीक है, यहां तक क्लियर हुआ? बताओ. ठीक. If till here it is clear, okay. If till here it is clear, then we will move forward. Okay. So थोड़ा कैटलिस्ट लेके डिस्कशन कर देते हैं. What is the main role of your catalyst? Okay, so while doing our rate constant, no, at that time we saw that our catalyst's main job is to decrease your activation energy. Okay, we saw it. Okay, that we saw it that for increasing the rate of the reaction there was two steps. That is, first one is your increasing the temperature and the second one was your decreasing your this activation energy. Okay, for increasing the temperature we provide energy and for decreasing the activation energy we use our catalyst. Okay, now this type of catalyst which decreases the E value and makes the reaction faster, makes the reaction faster, okay, or increases the rate. This type of catalyst is known as your positive catalyst. Clear? One more type of catalyst is there that makes the reaction slower. Makes the reaction slower. Okay, when we use this kind of catalyst, so suppose you are having a parallel reaction like this A to B, this A to C. Okay, now this A to C reaction, no, you have to stop it or you have to make it slow. Okay, so you use a catalyst such that this reaction activation energy, suppose this reaction activation energy is E1 and this one is E2, so you use a catalyst such that this reaction activation energy, this is your desired product, this is your undesired product, this reaction activation energy E2, it is increased. Okay, once it is increased, so what will happen? This A to C, this reaction rate will be decreased. If this rate is decreased, that means what? This catalyst is what this catalyst is doing? This catalyst is actually decreasing the rate of this reaction or making this reaction slower. This A to C, this reaction, it is making it slower. Okay, it may have no effect on your A to B. Let it be A to B. If there is catalyst, not catalyst, anything is happening, this A to B reaction rate, it is constant, it is not changing. However, this reaction rate, that is your A to C, this will be decreased. Okay, such kind of catalyst that makes the reaction slower is known as your negative catalyst. Okay, and it is also called as your inhibitor. It is also called as inhibitor. ठीक है, यहाँ तक समझ में आ गया? ओके, little bit we will see the curve also. How, what is the basic curve that is involved in here? Suppose this is your curve, okay, energy versus this, that curve is there, no, energy versus reaction path, okay, this energy versus reaction path is there, okay. Suppose this is your energy and this is your reaction path, okay. This curve is there, okay. This curve we couldn't discuss while we were doing our rate constant and theories of rate constant, okay. The reason is that we were not having time, was because this is a crash course, no, that much detail we will not be able to do it, okay. So you understand this, that this is the energy versus reaction path curve, okay. So this is the normal curve. Now suppose you are using a catalyst, so what will the catalyst do? It will just decrease the energy barrier. It will just decrease this energy barrier, okay. This is your without catalyst, and this one will be with catalyst. Okay. Your activation energy means what? Your activation energy is nothing but the energy barrier. Okay. Energy barrier means, activation energy means what? That amount of energy you have to provide the reactant molecule so that it moves to the excited state. Once it moves to the excited state, it will get converted into your product. Okay. You have a reactant, no? This reactant's amount of energy you have to provide. Okay. So amount of energy you have to provide. After providing this energy, this reactant will move to your excited state. Excited state, or this is only known as your activated complex, okay. Once it reaches to your activated complex, it will convert into your product, okay. So this gap between this reactant energy and this your excited state energy, this gap is known as your energy barrier, okay. And what this catalyst does is that it just decreases this energy gap. See here, this is your energy gap, this is your energy gap. So without catalyst, this energy gap was so much higher. With catalyst, the energy gap is so much lower. Clear? यहाँ तक क्लियर है? बताओ. Okay. If till here it is clear, then we will move a little bit forward. Okay. Now let us understand the steps in detail. That what are the steps that are happening in the heterogeneous reaction. Okay. Steps in the hetero heterogeneous reaction. Okay. So what are the steps that are involved in this heterogeneous reaction? जल्दी जल्दी करते हैं भाई. First step क्या है? First step is known as your external diffusion. External diffusion. The second step is known as your internal diffusion. Okay. The third step is your adsorption. The fourth step is your surface reaction. The fifth step is your desorption. The sixth step is your reverse internal diffusion. The seventh step is your reverse external diffusion. Okay. What these steps are meaning is that, suppose you are having a catalyst surface like this. Okay. This is your bulk. This is your liquid film or gas film that is present. Okay. Now understand what is going to happen. Understand what is going to happen here. So this is your bulk. Okay. So at the beginning, what will be happen? Your reactant will be present here in the bulk phase. Okay. From this bulk phase, it will diffuse and it will reach to this liquid film or gaseous film. Okay. This is your film, liquid or gas, as based on this like the phase that you are using. Okay. This can be bulk gas or bulk liquid. Okay. This film can be also either it can be gas film or it can be a liquid film. Okay. So this step where this reactant A is diffusing from the bulk to this film, the surface of this film, this is your step 1, that is your external diffusion. Clear? Second step is your internal diffusion. From this it will diffuse to the catalyst surface. Okay. This is your step 2. This is your step 2, that is your internal diffusion. From the liquid film it will reach to the catalyst surface. Okay. What is the third step? It is adsorption. Once this catalyst A, once this reactant A reaches to the catalyst surface, it will adsorb on the surface. Adsorption we have studied in mass transfer, no? So it will get adsorbed on the surface of the catalyst. Clear? After it is getting adsorbed on the surface of the catalyst, that is your step 3. Then it will participate in the reaction, surface reaction. That is your step 4. Okay. After step 4, your product P will be formed. Clear? Now this product P is in the adsorbed phase. Please understand this. This product P, this product P formed is in adsorbed phase on the surface of the reaction. Okay, this product P formed is in the adsorbed phase on the surface of the reaction, surface of the thing catalyst. Okay, now what is going to happen is that now this product P that is in the adsorbed phase, this will have nothing effect, no? This will have no effect, no? So what it has to do is that first it had to desorption. First it has to desorb. Okay, not desorb. Desorption. First it has to desorb. Desorb means what? First it has to move to this liquid film. Okay, from here, like it has to separate itself out. It has to separate itself out from this catalyst surface. Okay, it has to desorb from there. Okay, it has to separate out from this catalyst surface that is present here, P. Then it is going to have reverse internal diffusion. That means from this catalyst surface to this liquid film. Okay, from this catalyst surface to this liquid film, that step will be there. Then it will be reverse external diffusion from this liquid film to again the bulk. Okay, this is step number 7, step number 6, and somewhere here will be a step number 5. Clear? So these are the 7 steps that actually happens in a heterogeneous reaction. बताओ ये समझ में आया कि नहीं? सबसे पहले क्या होगा कि बल्क में रिएक्टेंट है, वो बल्क से रिएक्टेंट जो फिल्म है वहां तक पहुंचेगा, इसको हम लोग क्या कहते हैं? एक्सटर्नल डिफ्यूजन। फिर क्या होगा? फिल्म से लेके कैटलिस्ट सरफेस तक पहुंचेगा, इसको हम लोग कहते हैं इंटरनल डिफ्यूजन। अब एक बार रिएक्टेंट कैटलिस्ट सरफेस के ऊपर तक पहुंच गया तो फिर कैटलिस्ट सरफेस के ऊपर वो क्या होगा? एड्सॉर्प्शन होगा, उसके अंदर एड्सॉर्ब होगा। ठीक है, एड्सॉर्प्शन हो गया, वो अपना थर्ड स्टेप। एक बार वो एड्सॉर्ब हो गया तो फिर वो क्या करेगा? रिएक्शन में पार्टिसिपेट करेगा, रिएक्शन में पार्टिसिपेट करके वो प्रोडक्ट में कन्वर्ट हो जाएगा। ठीक, वो वहां तक पहुंच गया, वहां तक कैटलिस्ट सरफेस पे एब्जॉर्ब हो गया। कैटलिस्ट क्या किया? उसके एनर्जी बैरियर को डिक्रीज कर दिया। Once the energy barrier gets decreased, now at the same temperature the reaction will take place. You are getting it, no? Suppose you were providing some 5 joule of energy. Now when it was present in this bulk phase, at that 5 joule of energy, because your this activation energy was higher, so it was not able to participate in the reaction, it was not able to convert into product. Okay, once you have adsorbed it in the catalyst surface, the catalyst has decreased the activation energy. Now this 5 joule of energy is enough to like take that reactant to its activated phase and then convert it into product. Okay, so this product form, it is in the adsorbed phase on the catalyst surface. It has to remove, it has to move from there. So what it will do? It will do a desorption step. It will separate itself out from the catalyst surface. Okay, once it separates itself out, फिर क्या करेगा? अब वो यहाँ तक कैटलिस्ट सरफेस पे प्रेजेंट है लेकिन डिजॉल्व फॉर्म में प्रेजेंट है, तो वो रिवर्स इंटरनल डिफ्यूजन करेगा। मतलब कैटलिस्ट सरफेस से लेके लिक्विड फिल्म तक या फिर गैसियस फिल्म तक, वहां तक वो डिफ्यूजन करेगा। वहां तक डिफ्यूजन करेगा तो फिर क्या होगा? वो रिवर्स एक्सटर्नल डिफ्यूजन करेगा, मतलब फिल्म से लेके बाकी बल्क में आ जाएगा। समझा? तो ये जो 7 स्टेप्स है, ये है सारा मतलब डिटेल में स्टेप्स दैट आर इन्वॉल्वड इन ए हेटेरोजेनियस रिएक्शन। यहां तक क्लियर है कि नहीं बताओ? यहां तक क्लियर है भाई? बताओ, जल्दी बताओ, जल्दी जल्दी बताओ। ये चीज क्लियर हुआ? ये 7 स्टेप्स क्लियर है ना? चलो ठीक है। तो ये थोड़ा सा हम लोग डिटेल में इसके स्टेप्स देख लिए। हाँ ठीक है, ठीक है, चलो अब थोड़ा सा हम लोग मैथमेटिक्स में आते हैं। ठीक ना? अब थोड़ा सा अपने को क्या करना है? अब थोड़ा सा अपने को मैथमेटिक्स में आना है। ठीक ना? मैथमेटिक्स में क्या होता है, हम लोग एक चीज पढ़ते हैं कि हम लोग पढ़ते हैं पोर डिफ्यूजन। ठीक ना? व्हाट वी स्टडी इज दैट देयर इज अ टॉपिक देयर दैट इज नोन एज योर पोर डिफ्यूजन। Okay. In this pore diffusion, what we study is that we consider that we are having a cylindrical pore. Okay, please understand this. In this pore diffusion, what we consider is that suppose we are having a cylindrical pore. Okay, that is the length is your L. Okay, what is this cylindrical pore? This is just like this catalyst. Okay, suppose एक spherical catalyst है, उसका ऐसे ऐसे pores है, ठीक ना, ऐसे करके उसके ऊपर pores है, ठीक ना. इसको कैसे समझाए तुमको? You people have seen the golf ball. Hmm? Golf ball you have seen. How is the golf ball? It is round only, but it is having some like this kind of structures are there on it. Okay, some small holes are there, no, some small perforations are there. Now this perforations only if it is a little longer. Okay, if it is a little longer, then that is only known as your cylindrical pores. Okay, getting it? No, idea मिल रहा है? ऐसा टाइप का होगा ये, ऐसा सरफेस से लेके ऐसा सिलिंड्रिकल पोर होता है, ठीक ना. सो व्हाट वी से इज दैट दिस कैटलिस्ट इज गेटिंग डिफ्यूज्ड थ्रू दिस सिलिंड्रिकल पोर. ओके, that we are seeing, and as it is getting diffused through the cylindrical pore, the concentration is going on decreasing. Okay, the concentration is going on decreasing and reaction is taking place. Okay, suppose this is a cylindrical pore, so suppose this is your Z equals to 0 and this is your Z equals to L, that is your entire length of the pore. Suppose this is your CAS, that is the catalyst concentration at the surface. Okay, so as this will enter this cylindrical pore and will diffuse through the cylindrical pore, it will go on participating in the reaction, and as it is going on participating in the reaction, the concentration will go on decreasing. Okay, and at this point you will get some CAL. Okay, that is your final concentration. Clear? So what we say is that let us find out this concentration as a function of your Z. Let us find out this concentration as a function of your Z. Okay, function of your Z means that suppose you are having some Z is equals to 3 meter, some unknown Z, some Z is equals to 4 meter, or some Z is equals to something, anything at this Z distance. At this Z distance from the surface, we are able to find out the concentration of your A. आइडिया समझ में आया ना? पोर डिफ्यूजन का आइडिया क्या है? हम लोग बोले क्या कि पोर डिफ्यूजन में क्या हो रहा है, अपने पास जो कैटलिस्ट सरफेस है वो कैटलिस्ट सरफेस सिलिंड्रिकल पोर्स फॉर्मेट में है. मतलब ऐसा मान लो स्फेरिकल कैटलिस्ट है, ऐसा ऐसा करके सिलिंड्रिकल उसमें पोर्स है. कैटलिस्ट यहाँ पे कंसंट्रेशन CaS है. एज इट इज एंटरिंग दिस पोर इट विल डिफ्यूज थ्रू इट एंड इट विल पार्टिसिपेट इन द रिएक्शन. As it is participating in the reaction, its concentration is going on decreasing. Okay, so what is going to happen is that हम लोग बोले कि यहाँ से मान लो इसको Z is equals to 0 ले लिए और इसको हम लोग Z is equals to L ले लिए कि पोर का जो लेंथ है. ठीक, अब जैसे जैसे ये इसके अंदर डिफ्यूज करते जाएगा वैसे वैसे कंसंट्रेशन डिक्रीज करते जाएगा. कंसंट्रेशन अगर डिक्रीज करते गया तो हम लोग बोलते हैं कि ये जो पूरा फेनोमेना है इसको हम लोग पोर डिफ्यूजन का नाम दे देते हैं. वी कैन कॉल इट पोर डिफ्यूजन. एंड व्हाट इज आवर बेसिक आइडिया इन दिस पोर डिफ्यूजन इज we say that we will find out that at some random Z, suppose Z is equals to anything, at some this random Z, what will be the concentration of A? We know that at the input the concentration is your CaS. Okay, and at the output the concentration will be something. Okay, something, it will be something, let it be CaL, that is the concentration at your distance L. Okay, from the surface. Okay, this thing. Okay, so but at some random distance Z from the catalyst surface, what is the concentration of A that is present? Okay, if you can find out this concentration A that is present, you can find out the rate of the reaction, that is your R is equals to K into Ca. Clear? This is your basic idea behind your pore diffusion. ये चीज क्लियर है कि नहीं बताओ? Now we will just have to derive this. पोर डिफ्यूजन का कंसेप्ट क्लियर हुआ कि पोर डिफ्यूजन में हो क्या रहा है? ठीक है, ओके. सो नाउ वी हैव टू जस्ट डेराइव दिस. सो इसको डेराइव कैसे करते हैं थोड़ा सा देख लो. okay, उतना डिटेल में तो डेरिवेशन नहीं करेंगे क्योंकि फिर तो टाइम बहुत लग जाएगा. थोड़ा सा बस समझ लेते हैं. ठीक है, अब ये तुम्हारा Z इज इक्वल टू 0 है, यहाँ पे कंसंट्रेशन CaS है, ये Z इज इक्वल टू इज L. ओके, let this radius of this be capital R and the diameter be your D. Okay, what we say is that let us take a small strip. Okay, this strip starts at Z is equals to like Z, and it is of a thickness of dz. So when this reactant is entering it, it will enter at Z is equals to Z, and when it will be exiting it, it will be exiting at Z plus dz. Clear? क्लियर नो. एक स्मॉल स्ट्रिप हम लोग सिलेक्ट किए है इस सिलिंड्रिकल पोर के ऊपर जो इसका थिकनेस है अपना dz. So the entrance point distance is your Z and the exit point distance is your Z plus dz. Okay, from the starting. क्लियर नो? ये चीज क्लियर है? हम्म, ये चीज क्लियर है ना? बताओ. अच्छा, इनपुट पे कंसेंट्रेशन कितना है? इनपुट पे कंसेंट्रेशन है CaS। इनपुट पे कंसेंट्रेशन कितना है? इनपुट पे कंसेंट्रेशन है CaS। ठीक, ओके, यहां तक हुआ। हम लोग कुछ कुछ एजम्पशन भी लेते हैं। क्या क्या एजम्पशन लेते हैं? पहला हम लोग क्या लेते हैं? हम लोग फर्स्ट ऑर्डर रिएक्शन लेते हैं। फर्स्ट ऑर्डर रिएक्शन। What is the second assumption that we take? We consider it to be a steady state process. We consider it to be a steady state process. Okay. Steady state process means our accumulation will be equals to zero. As simple as that. Accumulation will be is equals to zero. As our accumulation is equals to zero, so now what are the things that are left? Apply the material balance, normal material balance. That is your input plus generation is equals to our output plus consumption and plus accumulation. Okay, what is your generation? That is your zero. What is your accumulation? It is zero, as because it is a steady state process. Why generation is zero? Because a, we are considering it to be a reactant, so reactant will only be consumed, it is not getting formed anywhere. So what is the basic like this thing you are getting? It is your input plus output, sorry, input minus output is equals to your consumption. इस डेरिवेशन को बहुत अच्छे से समझना, बहुत इंपॉर्टेंट डेरिवेशन है, ठीक ना? दिस सिलिंड्रिकल पोर डेरिवेशन आई विल डू इट इन द क्लास, एंड फॉर अ स्फेरिकल पोर, ओके, for a spherical surface, like suppose this is your catalyst surface, okay, from here in this spherical surface, this entire surface as a sphere, इसमें ऐसे करके अगर डिफ्यूजन हुआ तो स्फेरिकल के लिए स्ट्रॉन्ग, ये तुम्हारा पोर डिफ्यूजन के लिए व्हाट विल बी द रिलेशन दैट आई विल गिव यू टू डिराइव, ओके, ऑन योर ओन. Later on we will discuss it in the class, but for the cylindrical I am deriving it. You use the same idea as the cylindrical in the spherical and just derive it, okay. There's just a small change will be there. That is, in your cylindrical pore, what is going to happen is your cross sectional area, that is your pi r square, this is going to remain constant, okay. However, in this spherical pore, what is going to happen? This cross-sectional area, that is your pi r square, sorry, 4 pi r square, that is your entire surface area through which the diffusion is happening. This is not constant. Not constant. Okay. As it will be moving away from this surface, this area, cross-sectional area will go on changing. Okay. Or this surface area will go on changing. So that you have to apply your brain and you have to derive it. Okay. We will discuss it later on. But still, this you have to derive it. Okay. For the cylindrical pore, we will derive it now only. Okay. Just understand the same thing is the same thing you have to apply. Okay. Chalo. So input minus output will be is equals to your consumption. Okay. What is your input? What is your input? Okay. And you also know it that these derivations all we do it in terms of your molar rate. Okay. Molar rate. So this input, can we write it that flux at Z and into your cross-sectional area? Similarly, this output will be the flux at Z plus dz and into its cross-sectional area. यू आर गेटिंग द बेसिक आइडिया, नो? समझ में ध्यान से समझो इसमें क्या कर रहे हैं हम लोग. हम लोग जो मास ट्रांसफर के कारण जो लॉस हो रहा है ना, उसको इक्वल्स टू कर दे रहे कंजम्पशन. यू आर गेटिंग इट, नो? द फ्लक्स दैट वी आर लूजिंग इट due to mass transfer, that we are equating it with the consumption, that much amount of flux that we have lost, that must be equals to our consumption that has been consumed. Clear, no? Due to our surface reaction. You are getting it, no? What I'm trying to say, यू आर गेटिंग इट, नो? सपोज यहाँ पे फ्लक्स अपना Na था एट जेड, यहाँ पे फ्लक्स अपना क्या हो जाएगा? Na एट जेड प्लस डी जेड. ओके. This NaZ and this NaZ plus dz, there will be a difference in this flux, no? There will be a difference in this flux, as because this concentration of A is decreasing. This difference of this flux, we are equating it with your minus Ra into your V. Very simple. Nothing we are doing. Very simple. We are telling that this loss in the flux, that is taking place, that will in turn be equals to the consumption that is happening. Because this loss of flux, it is happening because of your surface reaction, no? This loss of flux that is happening, it is happening because of your surface reaction. So we are saying that this loss of flux, we will equate it with our surface reaction, the rate of your surface reaction. ठीक है? Acha. Your flux at Z, this can be denoted as minus dab into dou ca by dou z at Z. Normal fixed law of diffusion. Just fixed law of diffusion you have applied. Okay. Just J A Z thing you have written. Okay. And area. This area is what I said you. This area will be the cross sectional area. This cross sectional area of this cylinder, because through this area, this direction, the diffusion is happening. No. So this is just the cross sectional area of the cylinder, and that is your constant. That is your pi r square. The cross sectional area is not going to change. So that is nothing but your pi r square. So pi r square. Okay. Minus of. What is the flux at Z plus dz? It is minus dab into dca by dz at Z plus dz. Okay. And that 2 into area. Now area is again your pi r square. ठीक है. इसको अगर थोड़ा सही से लिखोगे तो ये तुम्हारा dab कॉमन ले लो, पाई और स्क्वायर कॉमन ले लो, तो तुम्हारे पास आ जाएगा डो सी ए बाई डो जेड एट जेड प्लस डी जेड एंड माइनस ऑफ डी सी ए बाई डी जेड at your z. It will happen like this. Nothing. This minus and minus will become make it plus. So this will and entire this thing we have taken it common. Dab into pi r square. Dab into pi r square. So this is becoming positive. So dca by dz at z plus dz minus dca by dz at z. Okay. This we have taken it one side and multiplied with this. We have your dab and our pi r square. Okay. This is nothing but our input minus output. Clear? Now we will move to the consumption. First just check if this input minus output is clear to you. नहीं, ये input minus output clear है ना? कैसे लिखे है इसको? बताओ. ठीक. ठीक. अब थोड़ा सा हम लोग कंजम्पशन लेके बात कर देते हैं. ठीक ना? कंजम्पशन क्या होगा? कंजम्पशन क्या होगा? Consumption will be minus RA double dash into your area. Okay. Don't make a mistake here. As in homogeneous, we were taking minus RA into V. Okay. As because the rate unit was, in that case, the rate unit was mole per meter cube second. So in order to make it mole per second, we were multiplying it with your volume, that is your meter cube. Okay. In this case, however, the rate unit is mole per meter square second. So we have to multiply it with our area, that is our pi r square. So this sorry, meter square. So this meter square will cancel out and we will get mole per second. ठीक ना. हेट्रोजीनियस में यही फर्क होता है कि इसमें हम लोग जो माइनस आर लिखते हैं, मतलब जो रेट लिखते हैं, एक्यूमुलेशन लिखते हैं, सॉरी जो कंजम्पशन लिखते हैं, वो माइनस आर इंटू वी के जगह पे माइनस आर इंटू एरिया लिखते हैं. इतना बस दिमाग में रखना. ठीक ना. तो ये जो माइनस आर इंटू वी लिखे ये वी नहीं होगा, ये होगा एरिया. As because here the rate unit is changed, it is RA double dash, so that is mole per meter square second. So in order to make it molar rate, that is your mole per second, you have to multiply it with meter square. Clear? यहाँ तक clear है? यहाँ तक clear है? बताओ ब्रो. ठीक. अब देखो. Now please understand carefully. What will be this area? Please understand carefully. This is your cylindrical pore. Your diffusion is taking place in this side. Okay. So that is our cross-sectional area. We have written it as pi r square. This is our diffusion area. Okay. Now what is our reaction area? What is our reaction area? This is the catalyst surface. No, please understand. This is the catalyst surface. On this catalyst surface, this reaction is happening. Clear? Please understand very carefully. This surface, this hollow cylinder, the cylinder is hollow in the between. Okay, it is hollow in the between. There, the reaction will not take place. It is a hollow. No. So hollow means there is nothing. Just our reactant is only present. The reaction will take place on the catalyst surface. This surface. This surface. That means this reaction will take place in this direction. The reaction will take place in this direction. Diffusion will take place in this direction. That is your axial direction. But the reaction will take place in this along with this catalyst surface. So that means it is going to take place in this direction. That is your radial direction. So which area will be responsible for your this surface reaction? This area will be nothing but your curved surface area. Curved surface area. That is your 2 pi r into dz, curved surface area. Why we are taking dz? Because this z is constantly changing, no? Getting it, no? This z is constantly changing. Or you can understand in this way also, that we have considered this strip, no? This only strip we are considering with a thickness of dz. Okay, so as because the thickness of the, or the length of this strip is your dz, so what is going to happen is that what will be the curved surface area of this small strip? It will be 2 pi r into dz, because the radius is same. The radius is your capital R only. हाँ, इसको कैपिटल आर लिख लो, नहीं तो कंफ्यूज हो जाएगा. सो कैपिटल आर ही लिख लो, इसको कैपिटल आर ही लिख लो. बस जो लेंथ है वो लेंथ अब टोटल, टोटल लेंथ इज योर एल, बट द लेंथ ऑफ दिस जस्ट स्ट्रिप इज योर dz. ओके, सो योर कर्व सरफेस एरिया विल बी 2 pi r into dz. यहाँ तक बताओ, क्लियर है क्या? ठीक, चलो अब देखो. हाँ ठीक है. अगर यहाँ तक अपना क्लियर हो गया, अगर यहाँ तक क्लियर हो गया, तो फिर अपना कंजम्पशन हम लोग टोटल लिख सकते हैं. कंजम्पशन विल बी इक्वल्स टू आवर माइनस आर ए डबल डैश इंटू आवर 2 पाई आर इंटू dz. इसको ऐसे लिख सकते हैं ना. And this minus r is nothing, it is just k double dash into your ca, isn't it? The rate constant into our ca, as because it's a first order reaction. This ca will be the, this ca will be the concentration at distance of z. This ca will be the concentration at the distance of your z. Distance of z from the starting. स्टार्टिंग से z है, एंडिंग से नहीं. ठीक ना? ऐसा मत सोचना कि मान लो तुम्हारा ये ऐसा है, सिलिंड्रिकल पोर जो है वो ऐसा है, तो यहाँ से डिस्टेंस, यहाँ से डिस्टेंस z है, स्टार्टिंग से. z इक्वल्स टू 0 टू z इक्वल्स टू z. Okay, so now nothing is there. Now you just, you have to equate it. So this you have to equate it with this, you have to equate it with k double dash into ca and into your area, that is 2 pi r into dz. Okay, from here this r, this one r, this pi will cancel out. Okay, this take it as capital R only. Okay, the same, the radius of the pore. Don't be confused that the capital small, don't be confused in this. Okay, from here you will be getting your dca by dz at z plus dz minus dca by dz at z divided by dz, that will be is equals to k double dash into ca into 2 and divided by dab. ठीक है, बताओ. यहाँ तक बताओ ब्रो, यहाँ तक क्लियर है? अगर यहाँ तक क्लियर है तो फिर एक चीज तुमको ऑलरेडी पता होगा कि अगर तुम एफ ऑफ एक्स एट एक्स प्लस डी एक्स माइनस एफ ऑफ एक्स एट एक्स एंड डिवाइडेड बाई डी एक्स, इसको हम लोग क्या लिख सकते हैं? एफ डैश ऑफ एक्स. ठीक है. और सिमिलरली अगर f dash of x into, like this is nothing, just the derivative, this just represents derivative. Okay, this just represents derivative of your f of x. Okay, suppose you are having f dash of x at x plus dx minus f dash of x at your x and divided by dx, so this will be what? F double dash of x, isn't it? Here what we are having in terms of f of x, in place of f of x, what we are having? We are having dca by dz, dca by dz and by dz. So this will simply be equals to d square ca by dz square, just the derivative of this dca by dz. समझ में आया? बताओ. ठीक है ना? Okay, so now overall what we got, overall what we got क्या मिला था? d square ca by dz square that was equals to your 2k double dash divided by r. नहीं, एक r भी होगा. Yeah, see, yeah, this r we have left it, no, this r is there, no, it was pi r square this side, it was 2 pi r this side, so one r cancels out, so one r will also be left, so this side one r will also be there. Okay, so we are getting 2k double dash by r and into ca, and this side we will be getting our dab. So this thing we will be getting. ठीक है. From this thing, what we are saying is that d square ca by dz square, that will be equals to 2k double dash by r into dab. Okay, and into your ca. Okay, this thing is there. Now what we are trying to say is that, let us consider this entire thing be equals to m square. M square is equals to 2k double dash by r into dab. And let us do one more thing. What we will be doing is that, let us do one more thing. What we will be doing is that, let us say that our dni, one thing, one second. Let us do one more thing. What we'll be doing is that this k thing, no, this ri is equals to this k into ca. Okay, what was the unit of this ri? कैसे करते हैं, रुक जा एक सेकंड. इसको ऐसे करते हैं ना कि आर आई इज इक्वल टू क्या था, 1/v इंटू डी एन आई बाई डी टी था. ठीक है, और आर आई डबल डैश इज इक्वल टू क्या था, 1/s इंटू डी एन आई बाई डी टी. ओके, सो व्हाट वी सेड इज दैट वी कैन इक्वेट दिस डी एन आई बाई डी टी, and this will be is equals to v into ri, and that will be is equals to s into ri double dash. Okay, what is your volume of the cylindrical pore? The volume of the cylindrical pore is pi r square into l. Okay, what is this ri? This ri you can write it as k into ca. What is the surface area of this cylindrical pore? Remember, we are considering surface reaction, so this will be the curved surface area. So what will be the curved surface area of this cylindrical pore? It will be 2 pi r l, isn't it? And what is this ri double dash? It is k double dash into ca. So ca cancels out, this pi cancels out, l cancels out, and oh, pi cancels out. अरे 2 cancel कर दिया गलती से, ये pi cancel हुआ. ठीक है, एक आर कैंसिल हुआ, एल एल कैंसिल हुआ. फ्रॉम हियर यू विल बी गेटिंग k इज इक्वल्स टू 2k डबल डैश बाई r. Okay, generally this is very confusing, that where we are using normal k, where we are using k double dash. Okay, so please be very careful in that. This thing is clear, no? This thing is clear, no? इसमें बहुत कंफ्यूजन होता है भाई कि किसमें k आ गया, किसमें k डबल डैश आ गया, क्या आ गया क्या नहीं आ गया. थिलेबोडुलस में k है, वो कौन सा k है, ठीक ना, उसका यूनिट क्या है, नॉर्मली के डबल डैश का यूनिट क्या है. ये चीज समझ में आया ना ब्रो, बताओ. ये जो के डबल डैश है वो कौन सा है, आर आई डबल डैश के कॉरेस्पॉन्डिंग वाला के डबल डैश, और जो नॉर्मल वाला के है वो क्या है, इसके आर आई के कॉरेस्पॉन्डिंग वाला के है. ठीक है, अच्छा. अब देखो, अब हम लोग क्या बोलते हैं कि एम स्क्वायर इसको लिख दिए 2k डबल डैश बाई आर इंटू डी ए बी. 2k डबल डैश बाई आर को के लिख सकते हैं, नॉर्मल वाला के, एंड डिवाइडेड बाई डी ए बी. इसको हम लोग लिख देते हैं एम स्क्वायर, और यहीं से हम लोग एम लिख देते हैं रूट अंडर के बाई डी ए बी. ठीक है, इसको भी एम स्क्वायर क्यों लिखते हैं वो अभी बाद में देखेंगे. पहले ये बताओ, ये डेरिवेशन क्लियर हुआ ना, द रिलेशन बिटवीन योर के एंड योर के डबल डैश, दिस थिंग इज क्लियर, नो? रिलेशन बिटवीन के एंड के डबल डैश, दिस थिंग इज क्लियर, नो? बताओ. ठीक है, अब कुछ है नहीं. अब इसको हम लोग एम स्क्वायर क्यों लिखते हैं, this will just be d square ca by dz square, that is equals to m square into ca. Okay, now you have understood why we are writing it like this. Okay, this is nothing but higher order differential equation. Okay, so this will become capital D square into ca minus m square into ca equals to 0. From here you will just take your d square minus m square, just take your ca to be equals to 0. From here you will form your auxiliary equation, that is your d square minus m square equals to 0, and your d will be equals to plus minus m. Okay. So what will be your solution? Your CA will be is equals to C1 e to the power mz. Your this variable is z only, no? And plus C2 e to the power minus mz. Okay. Like this you will be getting your CA. ये पढ़े हो ना भाई, ये पढ़े थे हम लोग, याद है? Mathematics we have done it. D square y minus dx square minus something, like let it be suppose k into y is there. Okay, this is equals to 0. So what we do, we take y common and we get this d square minus k equals to 0. From here we form our auxiliary equation like this. So d is equals to plus minus k. Okay. So if now there is no imaginary part, it is only different real parts. So for different real parts, your auxiliary equation or this thing is your complementary function. Your complementary function is this thing, like y will be is equals to c1 e to the power kx and plus c2 e to the power minus kx. ठीक है ना? तो वही है, सेम है, complementary function है, nothing, it is just complementary function. क्लियर? ये क्या है? होमोजीनियस, होमोजीनियस हायर ऑर्डर डिफरेंशियल इक्वेशन, होमोजीनियस सेकंड ऑर्डर डिफरेंशियल इक्वेशन. हाँ, बहुत अच्छे से पढ़े थे ना. ये डी स्क्वायर क्या होता है? डी बाई डी स्क्वायर, डी बाई डी एक्स स्क्वायर, लाइक दिस, डी स्क्वायर बाई डी एक्स स्क्वायर, दिस इज नथिंग, जस्ट डबल डेरिवेटिव. इसको मैथ्स में करवाए थे, बहुत अच्छे से करवाए थे. ठीक है ना, इसमें कोई कंफ्यूजन नहीं होना चाहिए. तो ये अपना सी ए हो गया. सी ए इज इक्वल टू क्या हो जाएगा? सी वन ई टू पावर एम जेड प्लस सी टू टू पावर माइनस एम जेड. दिस इज नथिंग बट अवर कंप्लीमेंट्री फंक्शन. नाउ वी हैव फाउंड आउट द कंप्लीमेंट्री फंक्शन एंड टू कांस्टेंट्स आर देयर और टू अननोन्स आर देयर, दैट इज योर सी वन एंड योर सी टू. For finding out the constant, we use boundary condition. So what are the boundary conditions here? At z is equals to 0, your CA will be is equals to CAS. At z is equals to your L, your dCA by dz will be is equals to 0. From where we are getting it? We said that after z is equals to L, please understand, we said that at z is equals to L, our cylindrical pore has lost, our cylindrical pore is over, no? The cylindrical pore started at z is equals to 0. Okay. It ended at z is equals to L. Once it ends here, now no reaction will take place. If there is no reaction, then the concentration of A is constant. So if the concentration of A is constant, that means we can write that our gradient of A, this concentration of A, that is dCA by dj, this will be equals to 0. As because this CA is now not changing with respect to your space or length. समझ में आया? बताओ, ये कंसेप्ट समझ में आया? Suppose in heat transfer, what we said, that suppose you are having a insulated area, insulated surface is there. At this insulated surface, your dt by dx will be is equals to 0. Means this temperature is not changing with respect to your space. Similarly, in this concept, here after z is equals to L, there is no surface reaction taking place. As because there is no surface reaction taking place, our cylindrical pore has ended. No surface reaction is taking place. So what is going to happen is that our concentration is becoming constant with respect to our space. No, now no matter what is going to happen, this concentration will of A will not change. So we have written our dCA by dz equals to 0. Clear? So you have got two boundary conditions and two unknowns are there. So applying these two boundary conditions, you have to just find out the values of your C1 and C2. समझ में आया ना? बताओ. अब बस बाउंड्री कंडीशन यूज करना है, बाउंड्री कंडीशन यूज करके C1 और C2 का वैल्यू निकालना है. Once you find out the C1 and C2 values, you put it in this equation, and finally you will get a equation that is your CA is equals to CAS into cos H m Z minus L divided by cos H ml. ठीक है? बताओ. 1 second. चलो भाई, यहाँ तक हो गया ना? अच्छा. अच्छा, अब पूछोगे कि सर ये तो ई टू द पावर में था, इसमें कैसे आ गया? तो ये सब चीज तो तुम लोगों को पता होगा, ठीक ना? तब भी एक बार हम लिख देते हैं. ये सब चीज पता है ना कि अपना cos हाइपरबोलिक x, इसको क्या लिख सकते हैं? e टू द पावर x प्लस टू द पावर माइनस x डिवाइडेड बाय 2. ओके. और साइन हाइपरबोलिक एक्स, इसको क्या लिख सकते हैं, ई टू द पावर एक्स माइनस टू द पावर माइनस एक्स डिवाइडेड बाई टू। ठीक है, तो ये सब में कंफ्यूज नहीं होना है। ठीक है, इसमें C1 C2 का वैल्यू पुट करोगे, फिर इस फॉर्मेट में आ जाएगा, e to the power x plus e to the power minus x divided by 2. Once it comes in this format, then we can convert it into cos hyperbolic your m into z minus l divided by cos hyperbolic m into l। बताओगे तो ये डेरिवेशन कर देते हैं, लेकिन जरूरत उतना नहीं है, खुद ही से कर लोगे, बेकार में टाइम वेस्ट का कुछ फायदा नहीं है। बताओ, इतना तक का डेरिवेशन कर दोगे ना, बाउंड्री कंडीशन अप्लाई करके C1 एंड C2 का वैल्यू निकाल लोगे ना। हाँ, इतना इसका उतना जरूरत नहीं है, डेरिवेशन नहीं भी करोगे तब भी चलेगा, इतना ये फॉर्मूला याद रखना बस हो जाएगा, और क्या। ठीक है, चलो, अब इसमें जो अपना बाउंड्री कंडीशंस था वो वेरीफाई कर लो। इसमें जो अपना बाउंड्री कंडीशंस था वो वेरीफाई कर लो, क्या है अपना फॉर्मूला, क्या आया है, फॉर्मूला आया है कि सी ए इज इक्वल टू सी ए एस इंटू कॉस हाइपरबोलिक एम इंटू जेड माइनस एल डिवाइडेड बाई cos hyperbolic ml. Okay. Now verify it. At z is equals to 0, we said our CA will be is equals to CAS. So check it. Check it if you are getting it not. At z equals to 0, what will happen? CA will be is equals to CAS cos HM. This z will be 0, so minus L and divided by cos HML. So you know cos minus theta is equals to cos theta. So this will cancel out. So you will be getting CA is equals to CAS. So our first boundary condition is verified. Okay. The second boundary condition what was that at z is equals to L, at z is equals to L, our CA will be is equals to our dCA by dz will be is equals to 0. So let us verify that also. So at z is equals to L, our CA will be is equals to CAS into cos hyperbolic m into L minus L divided by cos hyperbolic ML. Okay. This cos hyperbolic m L minus L means this is cos 0. So cos 0 is equals to 1. So this will become CAS by cos HML, and this is equals to your CA. Now this CAS is also constant, and this cos hyperbolic ml, this is also constant, because your L is constant, no, your L is also constant, and this m is also constant। ये L और M दोनों कांस्टेंट है, अगर L और M दोनों कांस्टेंट है तो फिर CAS भी कांस्टेंट है, वो तो सरफेस पे कंसेंट्रेशन है, और cos हाइपरबोलिक ml ये भी कांस्टेंट हो जाएगा, तो ये CA क्या हो जाएगा, एक कांस्टेंट के बराबर हो जाएगा, एंड डेरिवेटिव ऑफ ए कांस्टेंट इज इक्वल्स टू 0। सो दिस कंडीशन इज आल्सो वेरीफाइड। यहाँ तक क्लियर है? बताओ। So what is the formula that you are getting? The final formula that you are getting, that is equals to your, this formula you have to remember, okay? In case of pore diffusion, अरे कहाँ गया भाई, बोर्ड कहाँ गया यार, चला गया क्या? हाँ, so in pore diffusion, what formula you got? You got your CA to be is equals to CAS into cos hyperbolic M Z minus L divided by cos hyperbolic ML. Okay. Now here you can put any of your random Z and you will get your concentration at this random Z. Clear? That was only our basic idea. If till here it is clear, बताओ ये derivation सब कुछ समझ में आया कि नहीं, concept समझ में आया कि नहीं? सर इन बुक इट्स गिवन Z minus L। हाँ, तो हम लोग भी तो वही लिखे हैं। वही तो लिखा हुआ है अबे। अबे L माइनस Z माइनस L उसमें क्या है भाई, तो कॉस है, कॉस माइनस थीटा थीटा ही होता है ना, लिख दो उसको L माइनस जेड। भाई क्या है यार, गेट का तैयारी कर रहे हो कि बचपन में पहली बार कॉस फंक्शन पढ़ रहे हो यार? ऐसा ऐसा क्या चीज बोल देते हो यार? उसको लिख दो, हाँ जेड माइनस एल अपना नेगेटिव ही आएगा, उसमें क्या है? एल बड़ा है ना जेड से। जेड कुछ ऐसा बीच में होगा ना। और ये क्या है, एल क्या है, पूरा लेंथ है। तो जेड माइनस एल कुछ नेगेटिव ही आएगा, उसमें कौन सा बड़ा बात है? कॉस नेगेटिव पॉजिटिव ही होता है, कॉस माइनस थीटा इक्वल्स टू कॉस थीटा होता है, कुछ फर्क तो नहीं पड़ेगा। ये सर गॉट इट। अरे भाई ऐसा डाउट पूछेगा तो कैसे होगा ब्रो? लिख दो एल माइनस जेड, लिख दो, क्या है उसमें। ठीक है। ये अपना पोर डिफ्यूजन का फॉर्मूला हो गया, ठीक ना। अब इसके ऊपर वन मोर क्वांटिटी वी स्टडी। ओके। व्हाट दिस क्वांटिटी इज, दिस क्वांटिटी इज नथिंग, इट इज नोन एज योर थाइल मॉडुलस or Thiele modulus, anything you can call it, doesn't matter. Okay, this Thiele modulus. This Thiele modulus is given as your phi. Okay, this phi is denoted by m into L. Okay, what is this m? This m you already know it. It is root under k by dab, or it is also 2k double dash by r and into dab. Clear? ये अपना m है। m अपना पूरा कंसेप्ट m का क्लियर है, अभी ऊपर पूरा क्लियर किया है कि कैसे उसको k डैश को k में कन्वर्ट किया, वो सब कुछ क्लियर कर दिया। तो थाइल मॉडुलस क्या होता है, m इंटू एल होता है। ठीक। नाउ दिस थाइल मॉडुलस इज इक्वल्स टू m इंटू एल। तो अब क्या होगा, ये जो m है, मतलब दिस थाइल मॉडुलस इट विल बी इज इक्वल्स टू रूट अंडर k बाई डी ए बी इंटू योर l. Okay. However, please remember that this is only for your first order reaction. For first order reaction. This is only for your first order reaction. Okay. If suppose you want to do it for your nth order reaction. Okay. If suppose you want to like denote it for your nth order reaction, so this nth order reaction also you have to like write it. So your nth order reaction, write down the formula. So this phi will be is equals to root under n plus 1 into k double dash. Okay, divided by CAS to the power n minus 1 and divided by 2 into DAB. Okay, this is for your nth order reaction. इसको लिख लेना अच्छे से। ये क्या है, ये अपना nth ऑर्डर रिएक्शन के लिए, फॉर nth ऑर्डर रिएक्शन। ओके। और एक और काम कर लेना, इसमें जो है ना, इसको k लिख लो, नहीं तो तुम लोग कंफ्यूज हो जाओगे। ठीक है। नाउ व्हाट यू डू इज दैट you put here n equals to 1. Once you put here n equals to 1, what is going to happen is that n plus 1 1 plus 1 2, so 2 into k divided by 2 into dab and into cas to the power 1 minus 1 0 and into l, sorry एक l multiply करना भूल गया, so 2 2 will cancel out, this cas to the power 1 minus 1, that is cs to the power 0, it is equals to 1 only, so you will be getting root under k by dab and into l. This is your phi. Okay. So remember this formula. This is for your nth order. This formula you have to remember. यहाँ तक क्लियर है? बताओ ब्रो। अच्छा, nth ऑर्डर के लिए जो k यूज किए है वो नॉर्मल वाला k है, मतलब आर आई इज इक्वल टू वन बाई वी इंटू डी एन आई बाई डी टी, वो वाला जो k आता है उसमें ये वो वाला k है, ठीक ना। इसमें कंफ्यूज नहीं होना है कि ये क्या k होगा कि k डबल डैश होगा। अगर कंफ्यूजन हो रहा है तो डायरेक्टली सिंपली इसको n इक्वल टू वन पुट कर देना, n इक्वल टू वन पुट करके चेक कर लेना। देखो n इक्वल टू वन हम लोग पुट कर दिए, तो पुट कर दिए तो कट के ये रूट अंडर k बाई डी ए बी इंटू एल आ गया। और ये वाला k तुमको पता है कि ये वाला k कौन सा वाला होता है, जो भी वाला होता है। अगर यहाँ पे के डैश आना होता तो ये इस टाइप का आता। ठीक है, तो इसमें कंफ्यूजन बिल्कुल नहीं होना है। यहाँ तक क्लियर है, बताओ। ठीक है, अब हम लोग थोड़ा सा थाइल मॉडुलस के बारे में पढ़ लेते हैं। ओके, पहले एल पढ़ लेते हैं। पहले एल क्या है, कि जो एल है इसको हम लोग कहते हैं कैरेक्टरिस्टिक लेंथ। दिस एल इज योर कैरेक्टरिस्टिक लेंथ। ओके, दिस कैरेक्टरिस्टिक लेंथ इज गिवन बाय वॉल्यूम ऑफ पार्टिकल डिवाइडेड बाय exterior surface area available. Okay. Simply what you do is that for your flat plate, it will be L is equals to will be thickness by 2. Okay. For cylinder, this L will be is equals to radius by 2, and for sphere, this L will be is equals to R by 3. Okay. इतना याद रख लेना, इतना बहुत है। ठीक है। अगर यहाँ तक हो गया है तो थोड़ा सा हम लोग थायल मॉडुलस के बारे में पढ़ लेते हैं कि थायल मॉडुलस व्हाई वी आर डिफाइनिंग इट। ओके, लेट अस अंडरस्टैंड लिटिल बिट अबाउट योर थायल मॉडुलस। So this Thal modular we are defining it so that we can say that we can consider two cases. Okay, our case one is when our Thal modulus is high. Okay, high. So if our Thal modulus is high, so what are the possibilities that when our Thal modulus will be high? Our Thal modulus is actually equals to, that is equals to root under k by dab and into our L. So if our this phi value is high, that means what would have happened? This k value must have been high, this dab value must have been low, and this L value must have been high. All these three possibilities are there for our high Thal modulus. So either our k value is high, either our dab value is low, or our L value is high. As because this phi is directly proportional to your L, directly proportional to your k, and inversely proportional to your dab. If this k value is high, that means what? High reaction rate, और इसको और स्पेसिफिकली लिख लो कि हाई सरफेस रिएक्शन रेट. If this DAB value is low, that means what? Low mass transfer rate. And L value is high means L value is high. That means what? Large pore size. Because just now you have seen that for your cylinder, this L is equals to, your L is equals to radius by 2. So if L is high, that means what? Your R value, that means the radius of the cylindrical pore is high. So we can write it as large pore size. Okay. Or directly you can write it radius is high. Radius is high. ठीक है, यहाँ तक ऐसे लिख सकता है. ओके, वन मोर कंक्लूजन दैट यू कैन मेक इट. हाँ, वन मोर. लार्ज साइज मतलब क्या? ऐसा नहीं कि लेंथ लार्ज है, ध्यान से समझना. ओके, इसमें कंफ्यूज नहीं हो जाना है. ऐसा नहीं है कि सिलेंडर का जो लेंथ है वो लेंथ ज्यादा है. नहीं, लेंथ नहीं, पोर साइज मतलब तुम्हारा रेडियस, सिलेंडर का जो रेडियस है वो ज्यादा है. ठीक है. ओके, ये कंक्लूजन. और कंक्लूजन क्या है कि अगर के हाई है और डीएबी अगर छोटा है, तो इसका मतलब ये कह सकते हैं कि ये जो है ये तुम्हारा मास ट्रांसफर कंट्रोल्ड होगा. Because from childhood we are learning that our slowest step is the redetermining step. So the slowest step is the mass determining step, mass transfer step. So mass transfer step is having the, is the slowest step or is the low rate step. That means this will be our mass transfer controlled. So we can say that whenever Thal modulus is high, our this overall reaction is our mass transfer controlled. बताओ यहाँ तक क्लियर है कि नहीं? यहाँ तक क्लियर है ना? एक सेकंड. यहाँ तक क्लियर है ना? नाउ व्हाट इज द सेकंड केस? द सेकेंड केस इज योर लो थाइल मॉडुलस. ये लो है. ये अगर लो है तो फिर तीन पॉसिबिलिटी बनता है अपना. क्या क्या तीन पॉसिबिलिटी बनता है? पहला तो अपना के वैल्यू कम होगा, दूसरा अपना डीएबी वैल्यू ज्यादा होगा, और तीसरा अपना एल वैल्यू कम होगा. के वैल्यू कम मीन्स लो रिएक्शन, लो सरफेस रिएक्शन, लो सरफेस रिएक्शन रेट. डीएबी वैल्यू हाई मीन्स हाई मास ट्रांसफर रेट, एंड एल वैल्यू लेस मीन्स स्मॉल पोर साइज. और or the radius, it is smaller, small radius. And again, from these two, you can conclude that as our reaction surface reaction rate is low, that means surface reaction will be our slowest step. So you can call it as surface reaction controlled. So from the Thiel modulus, you can define or you can decide that whether the step is our mass transfer controlled or it is our reaction controlled. Okay, this is one. Or from the beginning, at the beginning we discussed one method, that if it is if your the overall rate of reaction is given in this format. So from here also you can decide based on these cases that which step is controlling. Okay. However, this is for your pore diffusion. Please remember, this is for your pore diffusion. Okay, this is for your pore diffusion. This entire thing we are studying it, it is for a specific case, that is your pore diffusion, a specific kind of diffusion. Okay, and that was in general. That was in general. This thing we did it for general. Okay, like if general in some mass transfer is happening and then some reaction is happening, so what, how to define our R overall. Okay, this is for our general, and this we are studying only for our pore diffusion. यहाँ तक बताओ क्लियर है कि नहीं? ठीक है, अगर यहाँ तक क्लियर है तो इसके बाद जो आता है कंसेप्ट, उसको हम लोग कहते हैं इफेक्टिवनेस फैक्टर। ठीक ना? इफेक्टिवनेस फैक्टर क्या होता है थोड़ा समझते हैं। चलो, इफेक्टिवनेस फैक्टर, दिस इज डिनोटेड बाय योर दिस एप्सिलॉन। ओके, इसको ऐसे डिनोट करते हैं, बहुत लोग इसको जीटा से डिनोट करते हैं, लेकिन जीटा से डिनोट करना सही नहीं है। इफेक्टिवनेस फैक्टर है तो कम से कम ई तो रहना ही चाहिए ना, तो इसको हम लोग ऐसे डिनोट कर देंगे। ठीक है, इफेक्टिवनेस फैक्टर क्या समझता है, क्या समझाता है, ध्यान से देखना। ये समझाता है रिएक्शन रेट with pore diffusion resistance divided by reaction rate without pore diffusion resistance। ठीक है, इसमें मतलब क्या होता है भाई, इसका मतलब क्या होता है ध्यान से समझना, कि रिएक्शन रेट विथ पोर डिफ्यूजन रेजिस्टेंस एंड रिएक्शन रेट विदाउट पोर डिफ्यूजन रेजिस्टेंस। ओके, सो if it is happening with pore diffusion, okay, so with pore diffusion means your minus Ra double dash, let it be some bar. Okay, and without pore diffusion means directly minus Ra double dash. Okay, so what is happening is that in with pore diffusion, what is going to happen is that in with pore diffusion, this CAS, it will not be constant every time. No, this CAS, please understand, in with pore diffusion, what is going to happen is that this CAS, it is going to decrease along the length. Okay, it is going to decrease along the length. Okay, and this CAS, it will like go on diffusing. No, it will go on diffusing. Okay, like this, the pore diffusion that just now we have learned. Okay, this CAS will go on decreasing along the length of this pore. Okay, so a constant concentration is not available. So our minus Ra double dash, we have to define it with respect to a average concentration. With respect to a average concentration, that is your Ca bar. This Ca bar is what? It is average concentration of A available in the pore. Clear? If suppose you are considering, this is your minus Ra dash. If suppose you are considering minus Ra normal, like without pore diffusion. So without pore diffusion means what? Now there is no pore diffusion happening. So just this surface concentration is available for you for the reaction. Just this surface concentration, it is available for you for participating in the reaction. No, इतना तक समझ में आया? बताओ, ये कंसेप्ट समझ में आया इफेक्टिवनेस फैक्टर का? दिस इज द बेसिक आइडिया ऑफ योर इफेक्टिवनेस फैक्टर। ओके, इसमें जनरली बहुत कंफ्यूजन रहता है, बहुत क्लाउडीनेस रहता है उसका, किसी को ये पूरा मतलब क्लियर ही नहीं होता है। ठीक ना, बहुत स्टूडेंट्स को। ठीक ना, ये चीज एकदम क्लियर है कि नहीं? इफेक्टिवनेस फैक्टर क्या समझता है, क्या समझाता है कि रिएक्शन रेट विथ पोर डिफ्यूजन एंड विदाउट पोर डिफ्यूजन। अगर पोर डिफ्यूजन है ही नहीं तो सरफेस पे जो कंसेंट्रेशन अवेलेबल होगा, जो कि है CaS, हम लोग रिएक्शन रेट डायरेक्टली उसी के टर्म्स में डिनोट कर देंगे। और अगर पोर डिफ्यूजन हो रहा है तो पोर डिफ्यूजन में क्या हो रहा है, जो कंसेंट्रेशन है वो कॉन्स्टेंटली डिक्रीज कर रहा है। अगर कॉन्स्टेंटली कंसेंट्रेशन डिक्रीज कर रहा है तो हम लोग कोई एक पर्टिकुलर कंसेंट्रेशन के ऊपर बेस करके रेट को डिफाइन नहीं कर पाएंगे। हम लोग को चाहिए एक एवरेज कंसेंट्रेशन। उस एवरेज कंसेंट्रेशन को हम लोग CA बार से डिनोट करते हैं। समझ में आया ब्रो? तो ये तुम्हारा क्या हो जाएगा, K डबल डैश इंटू CA बार डिवाइडेड बाई K डबल डैश इंटू CaS। सिंपली दिस विल बी योर इफेक्टिवनेस फैक्टर। बताओ भाई, ये चीज समझ में आया? Now this average concentration, again this average concept has came. So for average, you know it will be integration of 0 to L Ca into dz and divided by integration of 0 to L into dz. Nothing. It is just y into dx integration and divided by integration dx, where y is your function of x. Okay. This y here is what? This y here is Ca, where Ca is nothing but function of z, that is nothing but equals to CaS into cos hyperbolic m into z minus l डिवाइडेड बाई cos hyperbolic ml। यही हो जाएगा CA। तो CA क्या है, z का फंक्शन है, और हम लोग इसलिए z के रेस्पेक्ट में इसको एवरेज करने के लिए ऐसा यूज कर दिया है, इस कंसेप्ट को यूज करके। यहां तक समझ में आया? बताओ। अब कुछ नहीं करना है भाई, ये इंटीग्रेशन ऑफ 0 टू L dz तो जस्ट L हो जाएगा। तो CA बार विल बी इज इक्वल टू इंटीग्रेशन ऑफ 0 टू L CaS cos hyperbolic m z minus L डिवाइडेड बाई cos hyperbolic ml into dz, और डिवाइडेड बाई ये integration of 0 to L dz will just be equals to your L. Okay, this integration you have to do. It is a very simple integration. This CaS and cos h ml are constant, so they will come outside the integration. This cos h m z minus L, this will stay inside the integration. Okay, if this is staying inside the integration, so cos hyperbolic mz minus L, the integration of this will be sin hyperbolic। ठीक है ना, ये पता है ना? इसका इंटीग्रेशन क्या हो जाएगा, साइन हाइपरबोलिक एम जेड माइनस एल हो जाएगा, और नीचे एक एम आ जाएगा क्योंकि इसका डेरिवेटिव भी तो करना है। ठीक है, उसको करोगे इसका डेरिवेशन, इसका डेरिवेशन उतना इंपॉर्टेंट नहीं है। ठीक है, इसका डेरिवेशन करेगा तो ये ऐसा आ जाएगा भाई, देख ले, ये CaS कॉस हाइपरबोलिक ml, और ये वाला जो L है ये भी L यहाँ पे लिख दे रहे हैं। तो इंटीग्रेशन ऑफ 0 टू L कॉस हाइपरबोलिक m z माइनस एल इंटू dz। ठीक है ना? अब तुम लोगों को समझ में आएगा क्यों बुक में लिखा हुआ है L माइनस जेड, बट हम इसको Z माइनस एल लिख रहे हैं। इसको अगर L माइनस जेड लिखते ना तो नीचे एगो माइनस लगाना पड़ता एक्स्ट्रा, मतलब कुछ फर्क नहीं पड़ता, लेकिन बेकार में भाई काहे ला टेंशन लेना है माइनस वाइनस का। ये हो जाएगा तुम्हारा साइन, ये हो जाएगा अपना साइन हाइपरबोलिक m z माइनस एल। ठीक है, और नीचे इसके आ जाएगा अपना m, इसका लिमिट बैठ जाएगा 0 से लेके L तक। समझा? इसको अगर तुम L माइनस जेड लिखते तो नीचे एक माइनस लगाना पड़ता। ठीक है, कुछ फर्क नहीं पड़ता, इसमें जब लिमिट्स पुट करते ना तो वो माइनस इसमें माइनस आके वो कर जाता। ओके, नथिंग विल हैपन, बट स्टिल व्हाई टू टेक दैट बर्डन। सो दिस विल बिकम CaS ml into cos hyperbolic ml into put the limits, so this will become sin hyperbolic m in place of z we have to put L, so L minus L and minus sin hyperbolic m and into put this 0 here, so ये 0 इसको बना देगा minus L, so this will become minus L। Okay, so this is equals to 0, sin 0 is 0, so this will become CaS divided by ml into ये आ जाएगा cos h ml, और इंटू ये माइनस है और ये माइनस है, दिस माइनस विल कम आउटसाइड, साइन ऑफ माइनस थीटा इज माइनस साइन थीटा, so this minus will come out here, it will make it positive, so sin h ml। Okay, and from here only you write it as CaS into sin h ml by cos h ml, you can write it as tan h ml divided by ml, this is what, this is equals to your CA bar। This is what? This is equals to your CA bar. Okay, if you want to remember it, you can remember it. Till now, no question has been asked from it, but maybe someday or next year, this question is asked, that about this average concentration. Okay, then what is the rate of the reaction for your what is the rate of the reaction for your pore diffusion? Okay, so this minus RA double dash will be is equals to K double dash into CA bar. That will be is equals to K double dash into, instead of CA bar, we will be putting CAS into tan H ml by ml. Okay, so this thing, if you want to remember, you can remember it. Okay, now nothing is there. Now nothing is there. Simply your effectiveness factor. So your effectiveness factor, this effectiveness factor was equals to this CA bar by CAS. So this will be is equals to, what is your CA bar? It has came out to be CAS into tan H ml by ml and divided by CA bar. So CAS CS will cancel out, and from here only you write your effectiveness factor to be is equals to tan H ml by ml. Okay, now ml is equals to your phi. Okay, so from here only you write it as tan H phi by phi. समझ में आया? Effectiveness factor concept is clear or not? Very simple. For this effectiveness factor, this concept is clear or not? Hmm. Okay, now you tell me a basic idea. Now let us understand let's have a very basic idea. This effectiveness factor is equals to CA bar by CAS. Okay, from here we can write it, no? From here only let us study something, let us reach to a conclusion. Okay, if this effectiveness factor is equals to CA bar by CAS, and this CAS is the concentration at the input or at the surface, and this CA bar is the average concentration. So can we say that this average concentration will be less than this CAS? This average concentration will be less than this CAS, no? इसको कह सकते हैं, क्योंकि अगर पोर डिफ्यूजन, if pore diffusion is happening, then your concentration will go on decreasing, and at no point the concentration will be higher than your CAS. It will only be lower than your CAS only. And where if we are considering the average concentration over the entire pore, that is your CA bar, so this CA bar will of course be less than your CAS. And if this is possible, so can we say that this effectiveness factor will always be less than 1? बताओ, and it will be greater than 0. हम्म, बताओ भाई, जल्दी बताओ. ऐसा कर सकते हैं ना? And suppose we are considering this effectiveness factor at our input, just at z is equals to 0. So at this z is equals to 0, this CA will be is equals to CAS, that is our constant point. No? So if this CA is equals to CAS, and our, then that we can write that our CA bar is equals to our CAS also. Because अगर CA constant हो गया फिर तो कुछ हुआ ही नहीं ना. इधर देख, अगर z इज इक्वल टू 0 है, तो इस ये वाला जो हम लोग डेरिवेशन किए, जिसमें हम लोग CA का जगह पे ये पूरा फॉर्मूला लगा के उसको इंटीग्रेट किए थे, ठीक ना? तो उसमें तो फिर हम लोग CA का जगह पे डायरेक्टली हम लोग CAS पुट कर देंगे, अगर अपना z इज इक्वल टू 0 वाला पॉइंट पे लेना है. तो फिर CAS तो कांस्टेंट है, तो इंटीग्रेशन से बाहर आ जाएगा. तो फिर ये एल ऊपर और नीचे में कर जाएगा. हम क्या बोल रहे हैं, समझ में आ रहा है? ये अगर CAS हो गया और ये DZ हो गया, ये DZ हो गया, इसका 0 to L, इसका 0 to L, this CAS is a constant, no? So this will come outside the integration. This will now become like this, DZ. So this will cancel out. This CA bar will also be equals to your CAS. And if your CA bar is equals to your CAS, then this effectiveness factor will be is equals to 1 at input, or एट एंट्रेंस लिख दे. इनपुट तो थोड़ा अच्छा नहीं लग रहा है सुनने में, एट एंट्रेंस लिख दो, ठीक ना? इनपुट थोड़ा सा अलीप टाइप लग रहा है. एट एंट्रेंस और एट जेड इज इक्वल टू 0. ठीक है, बताओ. और इसी के ऊपर देखना लेवेंसपिल में कर्व भी होता है ना, जो अभी तक समझ में नहीं आ रहा होगा, लेकिन अब समझ में आ रहा होगा. ठीक ना। अभी तक तुम लोगों को पता ही नहीं चल रहा होगा कि हम लोग उस कर्व में सी ए बाई सी एस क्यों लिए हुए हैं वाई एक्सिस में। ठीक ना। अब अगर जाके देखोगे उतना इंपॉर्टेंट नहीं है, लेकिन अगर मतलब समझ में नहीं आ रहा है देखना है तो अब जाके देखोगे तो समझ में आ जाएगा, क्योंकि हम उसको सी ए बाई सी एस लिए हुए हैं। समझा। क्योंकि इफेक्टिवनेस फैक्टर जो एक्चुअली में तुम उसको लिख सकता है के डैश के डबल डैश तो कट जाएगा, तो उसको सी ए बार बाई सी एस भी हम लोग लिख सकते हैं। बताओ ब्रो, यहाँ तक समझ में आया? हम्म। यहाँ तक समझ में आया? क्रिस्टल क्लियर हो गया ना? अबे कहाँ से लाते हो भाई, सब लिखे हुए हो क्रिस्टल क्लियर। अच्छा, नाउ लेट अस अंडरस्टैंड वन थिंग। इसके बाद एक और कंसेप्ट आता है पोर डिफ्यूजन में ही, उसको हम लोग क्या कहते हैं कि स्ट्रॉन्ग पोर डिफ्यूजन रेजिस्टेंस। स्ट्रॉन्ग पोर डिफ्यूजन रेजिस्टेंस मतलब क्या, कि जो डिफ्यूजन रेजिस्टेंस है ये बहुत ज्यादा है। डिफ्यूजन रेजिस्टेंस मींस योर मास ट्रांसफर रेजिस्टेंस, this is very high. Mass transfer resistance is high means your DAB value is very low, isn't it? Please understand. कुछ देख के उतना डरना नहीं है कि अरे स्ट्रॉन्ग पोर डिफ्यूजन रेजिस्टेंस लिख दिया अब क्या होगा, ये क्या हो गया, ऐसा कुछ नहीं है। स्ट्रॉन्ग पोर डिफ्यूजन रेजिस्टेंस है मतलब डिफ्यूजन रेजिस्टेंस इज हाई। Strong pore diffusion resistance. So what is your pore diffusion resistance? Your pore diffusion resistance is nothing but your mass transfer resistance. If your mass transfer resistance is high, that means what? Your DAB value is less. Mass transfer resistance actually is what? Nothing but 1 by DAB. If this 1 by DAB is high, that means what? This DAB is less, no? If this DAB is very less, then what is going to happen is that this Thiel modulus is going to be high, no? This phi value, this Thiel modulus, it is going to be high. Okay. So for generally for this case, we say that okay, let us define a particular case. Okay. For this particular case, we say that if this phi value it is greater than 4, okay, then we can call it as strong pore diffusion regime. ओके, और स्ट्रॉन्ग पोर डिफ्यूजन रीजियन कुछ नहीं है। ओके, रिजाइम रिजियम ये सब जस्ट लिख के उसको बड़ा बनाया जाता है, कि कठिन बनाया जाता है, कि देखो रिजाइम लिख दिया। और इस केस में इफेक्टिवनेस फैक्टर जो होता है वो हम लोग 1/5 से हम लोग डिनोट करते हैं, बस और कुछ नहीं है। इफेक्टिवनेस फैक्टर जो होता है उसको हम लोग 5 से डिनोट करते हैं। ठीक ना। स्ट्रॉन्ग पोर डिफ्यूजन रीजन रीजियन में, रिजाइम में, रीजियन में जो भी है। ठीक ना। अब एक चीज ध्यान से समझना, एक्चुअली में इफेक्टिवनेस फैक्टर था क्या, वो था -RA डबल डैश bar divided by -RA डबल डैश। your effectiveness factor was this. If this effectiveness factor is actually equals to 1 by 5, if this effectiveness factor is actually equals to 1 by 5, okay, now please understand one thing, this -RA डबल डैश it is with pore diffusion, and this is without pore diffusion. Okay, this is with pore diffusion and this is with without pore diffusion. Okay, now understand one thing, this phi sorry this epsilon it will be is equals to -RA bar डबल डैश divided by -RA डबल डैश, that is equals to 1 by 5 in case of strong pore diffusion regime. From here can you write it that -RA डबल डैश will be is equals to -RA डबल डैश divided by 5? इसको ऐसे लिख सकते हैं क्या, बताओ? अगर इसको ऐसे लिख सकते हैं तो एक चीज समझना, -RA ये क्या हो रहा है? अरे भाई, चार्ज खत्म हो गया भाई पेंसिल का। अबे यार, 1 second, 1 second ना, विल जस्ट लेट इट चार्ज सम टाइम। थोड़ा बहुत चार्ज हो गया, चलो अब देखो। सो माइनस आर ए डबल डैश, दिस माइनस आर ए डबल डैश इज विदाउट पोर डिफ्यूजन। दैट मीन्स दिस माइनस आर ए डबल डैश इज नथिंग बट डायरेक्टली के डबल डैश इंटू सी ए एस to the power n. Let it be, let us derive it for nth order. Let us derive it for nth order. Okay, we are deriving, try to derive a very important thing from here. Okay, so this is let for nth order reaction. So for nth order reaction, this minus r double dash will be is equals to k double dash into cas to the power n. Okay, without port diffusion. Okay, so k double dash into cas to the power n. What is this phi value for nth order? Phi value for nth order, it is n plus 1 into k divided by 2 dab into cas to the power n minus 1। और भी कुछ रहता है क्या? और क्या रहता है ब्रो? ये एल रहता है ना एक, इतना ही होता है ना? चेक करो, भी ऊपर लिखे है, जल्दी से चेक करके बताओ। ठीक है, अगर ये होता है तो इसमें हम लोग को ज्यादा उसमें घुसना नहीं है, अपने को बस इतना चाहिए ना, हम लोग को बस इतना चाहिए कि अपने को सी एस को लेके वो करना है। ठीक है, माइनस आर ए डबल डैश, ये डायरेक्टली प्रोपोर्शनल टू हो जाएगा सी एस टू द पावर एन एंड डिवाइडेड बाई सी एस टू द पावर एन माइनस 1 डिवाइडेड बाई 2। ठीक ना, हम लोग को बस सी एस टू द पावर एन ये ऑर्डर लेके काम करना है। ठीक ना, तो यहाँ से ये माइनस आर ए डबल डैश बार विल बी डायरेक्टली प्रोपोर्शनल टू सी एस टू द पावर एन, और ये माइनस ऑफ एन माइनस 1 डिवाइडेड बाई 2 ऐसा आ जाएगा। तो इसको हम लोग ऐसा लिख सकते हैं ना कि n माइनस एन बाई टू प्लस 1/2। तो ये आ जाएगा सी ए एस और n प्लस 1 डिवाइडेड बाई 2। ये आ गया अपना माइनस आर ए डबल डैश। ठीक है, डायरेक्टली प्रोपोर्शनल टू सी ए एस टू द पावर दिस, और यू कैन कॉल इट एज कंसेंट्रेशन टू द पावर n प्लस 1 डिवाइडेड बाई 2। और यहीं से अपना वो आता है कंसेप्ट ऑफ n ऑब्जर्व्ड और n ट्रू का। ठीक ना, ये n क्या है जो यहाँ पे n है? दिस n इज योर ट्रू ऑर्डर ऑफ रिएक्शन, दिस n इज योर ट्रू ऑर्डर ऑफ रिएक्शन, ट्रू ऑर्डर ऑफ रिएक्शन। ट्रू ऑर्डर ऑफ रिएक्शन मीन्स एक्चुअल ऑर्डर ऑफ रिएक्शन। True means what? True or actual? Actual order of reaction. But however, in case of strong pore diffusion regime, in strong pore diffusion regime, it is not necessary that your actual order of reaction and your observed order of reaction both are same. Clear? Because this minus RA dash, this minus RA dash, that is your reaction rate with strong pore diffusion regime, that is equals to, or that is directly proportional to your concentration to the power n plus 1 divided by 2। Okay, so n observed is equals to n true प्लस 1 डिवाइडेड बाई 2। ये कंसेप्ट क्लियर हुआ? बताओ, ये बहुत इंपॉर्टेंट कंसेप्ट है, इसके ऊपर बहुत सारा क्वेश्चन आते रहता है। हम लोग सबसे पहले क्या बोले, ध्यान से देखना, अगर चार्ज में लगा देते हैं 6%। ठीक है, देखो हम लोग सबसे पहले क्या बोले कि अपना जो स्ट्रॉन्ग पोर डिफ्यूजन रिजाइम है उसमें फाई का वैल्यू बहुत हाई होगा। क्यों फाई का वैल्यू? वाई द फाई वैल्यू विल बी हाई? बिकॉज अवर डीएबी इज लो। ओके, बिकॉज अवर मास ट्रांसफर रेजिस्टेंस इज हाई। ओके, वेरी गुड। इफ फाई वैल्यू इज हाई, सो वी सेड दैट थ्रू थ्योरी इट इज ऑलरेडी डिफाइंड दैट इफ अवर फाई इज एक्सीडिंग अवर 4, okay, then we call it our strong pore diffusion regime, and in that case our effectiveness factor is already defined as 1 by 5. This is from theory, no need to derive this. Okay, this effectiveness factor will become equals to 1 by 5. Okay, if this effectiveness factor is equals to 5, sorry, equals to 1 by 5, then this effectiveness factor, through definition, it is actually the rate of the reaction with pore diffusion divided the rate of the reaction without pore diffusion. Okay, from here we can say that our rate of the reaction with pore diffusion will be is equals to rate of the reaction without pore diffusion and divided by our phi. This rate of the reaction without pore diffusion, it is nothing but equals to k double dash into cas to the power n, surface concentration to the power n, where n is the order of the reaction, or you can also call it actual order of the reaction or true order of the reaction. This phi value, we have already seen it for your nth order reaction. So that we have put it here. And through this, we have just derived it a little bit with respect to the concentration. And we have seen that this minus Ra bar, that is your rate of the reaction with strong pore diffusion regime, that is actually becoming directly proportional to this surface concentration to the power n plus 1 divided by 2. It should have been n, that is your normal actual rate of reaction or actual order of the reaction, but it is coming as n plus 1 divided by 2. So from here we derive the concept that in case of strong pore diffusion regime, our n observed order of the reaction that is actually observed is equals to n true plus 1 divided by 2. ये क्लियर है? ये कंसेप्ट क्लियर है? बताओ। अगर ये कंसेप्ट क्लियर है तो यहां से एक चीज ध्यान से समझना कि फॉर n ट्रू equals to 1, our n observed will be is equals to our n true. And if our n true is less than 1, in that case our n observed will be, अरे अगर n लेस देन 1 है तो 0.5 पुट करके देख लो ना, तो क्या आ जाएगा, ये तुम्हारा n ऑब्जर्व्ड इक्वल्स टू क्या आ जाएगा, 0.5 प्लस 1 डिवाइडेड बाई 2। 0.5 प्लस 1 मतलब 1.5, 0.75 आ जा रहा है। हाँ, तो फिर मतलब क्या हो जा रहा है, n ऑब्जर्व्ड is greater than n true. Okay, for n true to be equals to 0.5, your n observed is coming out as 0.75. So for n true less than 1, this n observed will be greater than n true. For this n true greater than 1, your n observed will be is equals to, okay, let consider कर लेते हैं, let n true be is equals to 2. So 2 plus 1 divided by 2, that is equals to 3 divided by 2, ये 1.5 आ जा रहा है। तो इस केस में क्या हो जा रहा है, n observed will be less than n true. ठीक है। So for the first order, the n observed and the n true will be same. If the order of the reaction is less than 1, in that case n observed will be greater than your n true. And if the order of the reaction is greater than 1, then it will be n observed will be less than your n true. यहाँ तक क्लियर है? बताओ। ठीक है ना, यहाँ तक क्लियर है ना? Okay, now just write down one more thing, that our activation energy observed, it is actually equals to E true plus E diffusion, okay, divided by 2. Okay, in general this E diffusion is negligible. Okay, that's why our E observed, we write it as E true divided by 2. If it is not negligible, then you have to consider it. Okay, this thing is there. And one more thing, from where this has come, no, nothing. Here we have, for the order of the reaction, we have compared this concentration, no, CAS. For the activation energy, what you have to do is that you have to compare this thing, this and this. These two you have to compare, and from there something will come, okay, in the power of this, like something k to the power something n will come. Okay, from there this e to the power this thing we have to match and then compare both these things. Okay, this will be k dash into Ca, like observed, Cas to the power observed. Okay, and this will be k dash observed. Okay, this will be is equals to your minus Ra bar, double dash bar. Okay, from this k dash observed and this k dash something a to the power n you will be getting. So these two you have to compare, and from there you have to derive it for the activation energy. Not that much detail is required. Okay, that will become too much deep. Okay, in this crash course that much, like what we are doing it is enough. Okay, इतना small time of time में उतना डिटेल में डेरिवेशन करना कर सकता है, अपने खुद में घर में जाके करना बहुत आसान है, जैसे सी ए का किया ना, द सेम वे यू हैव टू डू इट लाइक दिस। ओके, like this k to the power something will be coming, that you have to equate it with that and you will be getting it. Okay, mm. Think just something, just half is only coming, no, so with that you have to just do it. Okay, so from here you will be getting it like this. Okay, Actually, your E observed is equals to E true plus E diffusion divided by 2. This is the real one. Okay. However, your E diffusion is such less, it is negligible. So you go forward with this. E observed is equals to E true divided by 2. You can go forward with this. But however, if in the question this term E diffusion is mentioned anywhere, then you use this formula. समझ में आ रहा है ना हम क्या बोल रहे हैं? क्या बोल रहे हैं, समझ में आ रहा है? अगर E diffusion in the question it is mentioned, then you move forward with this formula. If it is not mentioned, you move forward with this formula. Okay. And now see what this actually means is that this activation energy that is observed, it is equals to the actual activation energy divided by 2. That means what is happening, are you getting it? In this strong pore diffusion region, the effect of catalyst, the effect of catalyst is so strong that this energy barrier, that is the activation energy, it is directly getting halved. ये चीज समझ में आया? ये जो ई ट्रू है ये क्या है? ये एक्चुअली में एनर्जी बैरियर है ना, ये एक्चुअली में एनर्जी बैरियर है ना, ये एनर्जी बैरियर डायरेक्टली हाफ हो जा रहा है, समझा? समझ में आया ये चीज बताओ? और ये एक्टिवेशन एनर्जी एन ऑब्जर्व मींस एन विथ पोर डिफ्यूजन है ना, मीनिंग हाँ बिल्कुल बिल्कुल बिल्कुल, इसमें क्या है, एन ऑब्जर्व मतलब एन विथ पोर डिफ्यूजन रेजिस्टेंस, मतलब ये एन ऑब्जर्व मतलब कुछ नहीं, ये जो माइनस आ रहे हैं ना, इसको अगर तुम के डबल डैश इंटू सी एस टू द पावर एन लिखोगे ना, तो इस एन को हम लोग लिखते हैं एन ऑब्जर्व, नथिंग एल्स, दिस विल बी के ऑब्जर्व। ठीक है, तो यही था जो था अपना हेट्रोजीनियस वाला पार्ट। ठीक है, तो ये चीज समझ में आ रहा है ना कि कैटलिस्ट का यूसेज क्या कर दे रहा है इन स्ट्रॉन्ग पोर डिफ्यूजन रिजाइम, व्हाट इज हैपनिंग इज दैट दिस यूसेज ऑफ दिस कैटलिस्ट इट इज like reducing this this activation energy or the energy barrier to half of its value. That's why the rate of the reaction inside the pore, no, it is very fast. Okay, it is very fast, and the mass transfer is your rate controlling. Okay, these things you are getting, no, as because this is getting half, so the rate of reaction inside the pore will be very fast, very fast, as because what you have done is that you have reduced the activation energy to half of its value. Okay, at the beginning of the CRE we understood that this, if this E value is reduced, our rate of the reaction will increase. In this case you have halved it, E by 2 you have done, so your rate of the reaction will increase very much. Okay, and as because this is increasing very much, your this the overall step is controlled by your mass transfer, because of course the mass transfer is slower, the mass transfer resistance is higher. Okay, यहाँ तक समझ में आया? बताओ। ठीक है, इसके बाद दो चीज और बता देते हैं भाई, बहुत इजी इजी चीज है, मतलब यही जो कठिन पार्ट मतलब कुछ नहीं, थोड़ा जो द कंसेप्चुअल पार्ट, नो, सो दिस वाज योर कंसेप्चुअल पार्ट। ओके, दिस मच इफ यू हैव अंडरस्टूड देन इट्स वेरी गुड, दिस मच इज द कंसेप्चुअल पार्ट। ओके, with this little amount of like formulas and all these things are there, little more amount of formula, just the formulas you have to know, so those formulas I will write it down. Okay, those formulas I will write it down, I will tell you later on. Okay, then in the next class we can discuss those formulas. Okay, I will just tell you the formulas, nothing is there. Okay, like yes, cylindrical, for the cylindrical you have derived this effectiveness factor, no, for this cylindrical for the cylindrical pore, yeah, कहाँ गया cylindrical pore, कहाँ गया भाई? Yeah, for the cylindrical pore we have written the formula of your effectiveness factor, no, that is equals to your tan h 5 by 5. Okay, so for the spherical pore what will be the effectiveness factor? Okay, that thing we will be writing it down. Then suppose this Ca and Cas relation, we have seen it for a cylindrical pore. Okay, if suppose it's a spherical pore, so what will be the relation between Ca and Cas? That we will write it down, that we will see. Okay, these things we will be seeing. And some little bit things I will tell you for solving numericals. Okay, and suppose gates. So what is going to happen is that you were having MFR in homogeneous, no? So in your heterogeneous you will be having basket type reactor. Basket type reactor. Okay. What was the formula of your MFR? It was V by Fa naught is equals to Xa by minus Ra. In basket type reactor, it will be W by Fa naught is equals to Xa by minus Ra. Done. Nothing else. Nothing else. Where this W is the weight of catalyst. No need to know anything else, you just know. If anywhere it is given basket type reactor, directly you use W as your weight of the catalyst, you use this formula and you get your answer. This minus Ra will be again the same. It's the first order, second order, third order, it will be depending on that. Okay. Then in your homogeneous, you were having PFR, no? So the PFR formula was V by Fa naught is equals to integration of 0 to Xa dxa by minus Ra. In case of your heterogeneous, you will be having packed bed reactor. This packed bed reactor is what? W by Fa naught is equals to integration of 0 to Xa dxa by minus Ra. Just instead of V, you put your W, and W is again the same thing. It is the weight of the catalyst. Okay. Till here it is clear. बताओ, यहाँ तक समझ में आया? ठीक है। और क्रैश कोर्स को थोड़ा सा और आगे बढ़ने दो, 2-3 सब्जेक्ट और हम लोग खत्म कर लेंगे। तो इसको खत्म करने के बाद हम लोग क्या करेंगे ना, जो मतलब अगर सिलेबस अपना खत्म हो गया, तो सिलेबस अगर खत्म हो जा रहा है तो फिर उसके बाद हम लोग वो दोनों देख लेंगे। थोड़ा सा कैटलिस्ट डीएक्टिवेशन वाला पार्ट और एंजाइम काइनेटिक्स वाला पार्ट, वो सब हम लोग देख लेंगे। ठीक है। बट मेन जो वो सब कुछ नहीं है, वेरी इजी है। ओके, लाइक इफ दिस थिंग वी हैव अंडरस्टूड, नो, like this today what we have discussed, that was the main important part, that was the main conceptual part. If this much part you have understood, then those things are not there. I think the entire concept is clear for you. Like for what is your CA bar, what is your effectiveness factor. Generally with these things, like it is, we study it very cloudy. When I used to prepare back, then everything was very cloudy. Nowhere, no clear concept was available. Okay, one Levenspiel was there, but the language of Levenspiel, it is such like it is very difficult to understand. Okay, so ऐसा है, ठीक है। हाँ हाँ, दो मैकेनिज्म है, उसको सरफेस काइनेटिक्स कहते हैं, अभी उसको बता देते हैं। Okay, that is your surface kinetics. Okay, that we will discuss in the beginning of the next class. Okay, in the beginning of the next class I will discuss that. That is nothing, your surface kinetics. Only two mechanisms are there. One is your Langmuir mechanism and Langmuir-Hinsel-Mood mechanism. One is your Eller-Riddle mechanism. It will take 10 minutes. There's one trick I'll tell you, you will be able to solve all the questions. Okay, and this was the important part. ये आज जो अभी जो किए वो important है भाई, वो सब कुछ नहीं है भाई, वो सब कुछ नहीं है, कुछ नहीं है, कुछ नहीं है। क्या कंफ्यूज होता है? कंफ्यूज तो तुम लोग इसमें भी होता होगा। ठीक है, आज के बाद कंफ्यूजन नहीं ना होगा। जो बोल रहे हो कि उसमें कंफ्यूज होता है, तो कंफ्यूज तो इसमें भी होते होगे। ये अभी तक पता तुम लोगों को थोड़ी था कि इफेक्टिवनेस फैक्टर क्या होता है। बस फॉर्मूला जानते थे, ये फॉर्मूला है। ठीक है, उसको इस तरीके से लिख सकते हैं, डेरिवेशन कैसे होता है, फॉर्मूला कैसे होता है। ये सब इतना कंफ्यूजन, इसमें तो इतना कंफ्यूजन था, अब तो पूरा, हाँ तो होगा ही भाई कंफ्यूजन, इसमें पता है हमको, कहीं पे कुछ नहीं था। एसपीडीआर क्या होता है? एसपीडीआर मतलब क्या होता है? हाँ सर, इसमें था कंफ्यूजन, एसपीडीआर। अच्छा, स्ट्रॉन्ग पोर डिफ्यूजन रेजिस्टेंस, अरे बाप रे। ठीक है, जो हो। तो अब क्लियर हो गया होगा, हर चीज का शॉर्ट फॉर्म यूज कर देगा, कैसे चलेगा। ठीक है, ये समझ में आ गया ना? अभी नेक्स्ट क्लास स्टार्ट करेंगे, नेक्स्ट क्लास के स्टार्टिंग में हम लोग क्या करेंगे, वो कर लेंगे, क्या बोलते हैं उसको, सरफेस काइनेटिक्स कर लेंगे। ठीक ना? थोड़ा सा इसके ऊपर एक ग्राफ है, उस ग्राफ को हम एक्सप्लेन कर देंगे, ये हेट्रोजीनियस के ऊपर। ठीक है, एक तो ग्राफ एक्सप्लेन कर देंगे, थोड़ा सा हम लोग सरफेस काइनेटिक्स का वो कर लेंगे, लैंग्वेज, हिंसेलवुड और एलेरेडल। और हम लोग क्या करेंगे, हाँ अभी जो भी डेरिवेशन किए वो सिलिंड्रिकल पोर के लिए किए, स्फेरिकल पोर के लिए डेरिवेशन पूरा नहीं करेंगे, बस क्या चेंज होगा वो देख लेंगे और लास्ट में जस्ट एंड एंड रिजल्ट्स लिख लेंगे। ठीक ना? फिर अपना जो नेक्स्ट टॉपिक है उसको स्टार्ट करेंगे, आईपीसी का रिवीजन करना है ना, उसको आईपीसी का पूरा रिवीजन कर लेंगे। ठीक है, तो अभी तो इसको एंड करते हैं। ठीक ना। अभी इसको एंड करते हैं, बाकी चलो ग्रुप में बताते हैं कितने बजे स्टार्ट करेंगे, ग्रुप में बताते हैं। ठीक है, चलो एंड करें। बताओ भाई जल्दी। एंड करें ना। चलो ठीक है, ठीक है। हाँ थैंक यू, थैंक यू, ठीक है।